Good morning, everyone. Hello. I'm currently blind. Give me a second because Chatterino has its login info has expired. I'll need my phone. All right. I'm no longer blind. That's good. So today's plan is to make some progress on the Wasm support, and with that also support for non-x64 targets, because that's currently a pain as far as I've heard. So I wanna just make that a bit easier for people. I still haven't had breakfast, so you might have to sit through a bit of my munching while we look at the state of things, etc. Let me just open up. John forwarded a couple of mails to me. Because I asked him for anything he has on changes that people have submitted regarding non-x64 targets. So we might start by just incorporating those and then having a look at what else is broken. So I started on Discord. I started a thread, and it seems like Patrick has made big progress on Wasm in general. So I think we'll start by trying out his Wasm plugin and seeing if we can make progress on that. Because I don't think it uses our cross-compiling capabilities. Maybe it does. We'll have a look. So that's the plan for today. Just making some progress, as much as we can actually, on Wasm. And just making things easier. Because the reason I started this is I see in the Discord people over and over trying to get Wasm to work, and everyone has their own hacks of trying to do it. And I have the feeling we're burning a lot of goodwill and energy from lots of people because they have to recreate hacks and figure things out that we could probably just document in the thing that we ship with the compiler, because so many people are interested in it. I'm actually surprised, but that's what it is. So yeah, we'll do that in a minute. We have Kyuko in stream. That's good. I don't know if anyone else is here that has Wasm experience. Okay, let's start easy. I feel it easy. Hey Enzybot, hey Bakersonge, hey all people. Okay. We compile. I'm just making sure that we're in a workable state before we start. Come on. you can feel the delay that Rosetta causes. If I recompile the compiler, the first compilation always stalls for like a couple of seconds. Okay. I start with one of Ian's changes. Because he's added some fallbacks to Apollo time, which uses lots of Wasm. So we want to get that out of the way right away. So I'm just going to take his changes and drop them here. And then we'll take a diff. Okay, that's Apollo time, and the other one was int 182. Is this something that existed before or not? And why can't I see it here? Why don't I see int? I just saved it here. That seems to not have worked. There it is. Is this something? Yeah, that's something we ship. Okay. Okay, let's look at what that changed. Yeah, this is perfect. This is what we basically have to do everywhere. There are some style issues. Let's try to not cause more of those. Oh, here we still have okay, so this is Ian's backup basically for this one. Okay, so this is uppercase because it's a macro, I guess. I didn't know that naming convention. Okay. Here, I see here we're doing this. Okay. Just to get a feeling for where we're at. Kuyuku, have you tried the Patrick's Wasm, and have you looked at how it differs from yours? Just, or do I have to do that? Okay, great. Do you want to hop on a call or something? Although I don't know how we get your voice back into... I don't think I have the bridge installed. Let me have a look. No, I don't have any audio bridge installed, so I don't think I can recapture your voice on the stream. So maybe that sucks. Maybe we'll have to figure that out, but that might require us restarting OBS. Yeah, I'll have a quick look. Damn, I need the next macOS for it to work in OBS. That's annoying. So what I'm looking at right now is this one. So in macOS 13, looks like you can just natively do it. Finally. I'm on 12 still. The problem is, I bet this would require us to restart OBS. But we can try it. No, my OBS setup is not crazy, but on macOS by default, at least up until 12, it seems, you cannot capture the desktop audio source directly. You have to have a virtual audio device, basically. And I've never needed it, so I never set it up. But if we have you on call, it would be nice if people can hear your voice, not only through my speakers. Like, we can try it, but basically the effect is going to be, I'm going to have to use the studio display's speakers to hear you, and that people can hear you through the mic again. It might suck. We can give it a try. But you know what? I'm just going to quickly try this. If I can set it up. Application capture. Might work, yes. So I'm just capturing from Discord or something. I don't think that works, but... Okay, let's see. Audio input capture. You know what? Let's do this here. Okay, this is my setup right now. I'm trying... No, this is just... So Microsoft Teams audio shows up here, so they seem to add an audio bridge. But this doesn't work. Nope. So... Where is it? What else do we have? Doesn't look good. Nope. I got some duplicate mic input now. You mean right now, or was it just when we had this one? Yeah, it was just because I had the audio source in there twice. Because when I tried to change it, it didn't work. Okay. Browser capture with Discord in the browser. That still wouldn't give you audio. That would still give you just a browser window. So I think we'll try this for a second. And we'll see how good macOS is at doing these things without having to reboot or anything. I have the feeling I might have to restart OBS. We'll give it a try. But maybe this is a reason to upgrade to macOS 13 finally. Like, I postpone all macOS updates as long as possible. That's why I'm still on 12. But this might be a reason to update to 13. I'm gonna hate it, but... Thank you, I'm not interested. Successfully installed. Oh, there we are. Okay. Let's see. Where's the... This is not... Audio media set. Audio. There we are. Okay. So sorry that we have to do this. On stream, but that's how it is when you're not prepared. So we want a multi-output, and we want the VB cable, and what else actually? Uncheck. I want to hear the Yeti because I'm going to use earplugs so we don't get echo. What? And then I check this one again and... Yes, okay. Good. So we have that. And now we go back to system settings, audio. We say my output is the multi-output device. I'm surprised. Okay. Good. Yeah, Sonoma is 14, but this works in 13 or later, Ventura, and I'm still on 12. I'm not going to update to 14 until something forces me to 14. Like, again, I postpone this as much as possible because software quality, Apple software quality has been degrading reliably with every version, so I'm not going to update more than I have to. Okay, we have that set up. I don't know yet if it works, but we'll give it a try. And now we have to make sure that I can switch the audio source here. Audio, desktop audio, VB cable, I guess. Okay, and now if I turn this on, we should hear something. We'll just try it live. So I'm gonna give you a call. I'm gonna plug in my earplugs. And then people can tell me if they can hear you, and if I can hear you. Where are you? Let's do, the problem is if we do audio only, you're gonna have a lag from the stream. That's not ideal, so we probably do an audio video call and hope that my bandwidth survives it. Guys, in the chat, let me know if things suck now. Okay, so I can't hear you, that's no good. Yeah.
Hey.
Ah, yay, that worked.
Me?
Hey, yeah, I can hear you. Stream, can you hear him? Let's see, desktop audio shows nothing right now. Say something.
Test.
Yes. Okay, test. What does stream say? We can hear. Yay, success.
Yay.
No reboot necessary, no OBS restart necessary. That's actually a positive surprise. Awesome. He's louder than me. That's intolerable. No, let's cut that down. That's no good. I can turn up my volume as well. So, okay, good. Hey, nice to hear you. We haven't heard each other
How's it
ever.
going?
Yeah, good, good. I'm crazy tired because my youngest one had a bad cough this
Uh-oh.
night. So I'm not sure how good my concentration is gonna hold up. But we'll give it a try. Okay,
No worries.
so
So yeah,
what's the
so I can give you a
situation?
bit of a rundown of my understanding here
Yeah,
of so the difference in my library and his so
just
the
let's
main
open
thing
them just
now
so that people know what we're talking about. Um,
here, do you want me to you're opening this on your stream? You want me to stream my VS Code or how
no,
do you want to do it?
I'm gonna. Oh yeah, I'm gonna. So first thing is I'm gonna share my screen, or you can share yours, whatever you like. Like if you're willing to share your screen, I can put it on screen, or I can just share mine and open everything. Maybe that's yeah. Let's do that. Maybe.
Yeah,
So
probably is
I'm
better.
gonna share my whole screen one. That's huge though, but you can handle it. No, you can't. I can do only 720p. That sucks maybe a bit. We'll try it. Tell me how bad it is. Um,
You can maybe lower frame rate. Maybe down to 15, I'm not sure.
yeah, but that doesn't help because the resolution is still only 720. So
Oh, okay.
I'm just worried that you can't read anything. Okay, I'm gonna open up the Wasm from Patrick. Ta-da! And now
The
yours is
stream is
in here as
not
well.
yet working.
Not yet working.
It's like
No.
perpetually loading. I could, I don't know how bad the delay is. I could just watch your stream.
Yeah, you're gonna have at least a 3 or 5 second delay. I'm not sure if that's great. Um, hey Patrick. Yeah, awesome. Um, so I'm gonna just stop the streaming for a second and try to reshare. Technical difficulties, guys. We're figuring this out. So let's try that again. Screen one. Give it better readability of text. Oh, with 5 frames per second. Ugh. We'll try it. Whatever. Let's see if we can get it to show up at all. Come on,
Oh, there we
Discord, you can do it. Nothing?
Nope, nothing yet.
Yay. Awesome. Um, okay, we'll try something else. I'm gonna give you just the browser window for now. And then we go for this one.
Well, it's
Okay.
browser, yeah.
Yeah, that's
We have
just the
that.
browser. Okay. Good. So this is Patrick's Wasm plugin, and I'm gonna open yours as well, and then you can run me through what's working, what's not working, what's different, etc. Where's
Yep,
yours? You linked it somewhere. Current library. Is that the right one?
that's right. Yep.
Okay. So let's hear it while I munch on my
So
breakfast.
yeah, so I think Patrick's is more like simple
Mm-hmm.
and in a good way. Like probably more well made. Mine's kind of like messy and all over the place. And Patrick's implemented it as a plugin, which mine originally did not.
Mm-hmm.
And so I think he is using your new retargeting thing where his target is WASM dash unknown or something like that.
Mm-hmm.
I think that's what you were talking about. Yeah. And so the main difference at this point, in order to get mine working, mine has been like dead code for a year. I kind of just like updated a lot of what the changes he made. And so some of the main differences is now he has Wowlock or whatever that is, the
Mm-hmm.
actual allocator for WASM working. That's a big difference, right? And so that's huge. You
Yeah.
can actually allocate code. That's really kind of the main thing. The other thing here is that his is set up as just a plugin,
Mm-hmm.
which is like convenient for quick testing. If you have an actual main meta program to compile your project,
Yep.
then well, yeah. So I I guess his plugin would probably work for that as well. So that brings me to the second thing is that mine has replacements for individual methods, and his has a replacement for the runtime folder now. It seems like that's the new change he posted today.
Mm-hmm.
I don't know much about. He'd be better to comment on that runtime folder replacement. I'd actually be really interested to learn kind of the reason for that.
Mm-hmm.
That's an interesting choice here. That may be a good thing to look into. But so mine has a yeah like method body replacements where you give it a header and a new method body, and then at like type check time it swaps out the bodies,
Mm-hmm.
which I think it's a solution. I think it's really janky. There has to be a cleaner way to do that type of thing.
Yeah.
But something like that I think is necessary, and that's probably one of the main issues where I think that's what he was trying to accomplish with his runtime swap out. But well, anyways, I'm getting off track. But so those are the main issues I think, or the main differences here. And otherwise, all the WebAssembly libraries, in my opinion, are pretty similar.
Mm-hmm.
I guess the other main difference, I think he's doing some stuff. His runtime things seem to do some stuff with how the or how the actual code is initialized, like before it calls main,
Mm-hmm.
which is I don't know much about that, but that's a whole thing. He seemed to do some WebAssembly specific stuff there that I'm not doing. So my alternative to that was what TS Odings, I don't know how you say
Yeah.
his name.
I say
It was what he
just
was
say
doing.
soding. It's probably wrong, but yeah.
Yeah. Uh, that's what he was doing where I think that's what he was doing. He started, so when you like initialize this WebAssembly instance, whatever thing, in the actual JavaScript code, it gives you back all the methods. And so someone's solution, which is what mine does, was to basically get the main program
Yeah.
and you call the main program. The main program calls into set context, which is another bound, like externally exported method. And so from set context, uh,
Where
how
does
does
it
this work?
happen? Where does it happen in here? Just so that I can have a visualization of what you're talking about. So this is yours. Um, where
So
does all the magic happen?
the main thing is an example. Actually, just go to example. That would
Mm-hmm.
be most relevant here. Yeah. So in a source
Sure.
game, so this is set context here. So it's passing the context pointer. And this is just because every method in Jai that's, not a C method or not a no context method has to like secretly have this,
Yeah,
right?
sure. Yeah.
And so with this, you can, I think the set context method, if you open, where is this now? Probably plugin down at the
Yep.
bottom. Yeah. And then Jai bindings, I think.
Mm-hmm. Oh yeah, here you
So
have a
here we go.
foreign, so
So
this
these are the
means it's
exported. Yeah.
call. That's why you have to pass it explicitly because it's call, so it's not
Yeah,
going to
this
get
is
the
this is what
context yet.
Patrick set up. Yeah, this
Mm-hmm.
was his thing here.
Mm-hmm.
So this is setting, yeah. So and so if you want to see the mapping of this, I think still the best thing to do is an example, probably, yeah. In the example folder, there
Yep,
is
sure.
in public, there is
Let's go over
the
here.
JavaScript
Yeah,
code.
public. Oh yeah, okay, good.
So the relevant one here is Jai,
I'm just gonna look here how
Jai,
it's set
Jai.
up.
Yeah, sure.
So you're loading Jai.js and then initialize loop render. Which one of those is the one you compiled from Jai? This one?
Wait, repeat that. So the Jai contains the bindings, yeah. And so there's two things. Maybe the first thing to look at is initialize, just to
Sure.
go through the flow here.
Yeah.
So on actual window initialize, it's just calling Jai initialize and it's passing in exported, which is just this blob of JavaScript functions.
Yes. Mm-hmm.
So these are actual callbacks that you can call in Jai.
Yeah, I
So
remember.
if there is
Yeah.
something, yeah.
Mm-hmm.
So that's all. Now this you can just go and I thought it was more complicated than that. You can just open up jai.js then, where the actual stuff's happening.
Mm-hmm.
And I think Patrick's is more simple, maybe better to look at this point because mine is doing quite a lot of stuff here.
Okay.
But whichever way.
Yeah, Patrick, if you want to hop on the Discord call as well, let me know. We haven't like talked about this before, but if you want to just walk us through your solution via audio, be my guest.
Um,
Okay, but if we go here, this is his example. So we have just a main with a compile instruction. So you give it the path to Wasm plugin, say plug Wasm. Yeah. One thing that I just wanted to note, yours is just Wasm Jai, so I can't just take this whole thing and clone it into my modules folder, right? Which I'd love to do. So I'd love if this was a module.jai, but maybe you using it differently and then it's fine that it's just a wasm.jai. Hey, Jumpy. Yeah, this is the party. Uh, okay, so he does um, just some simple printing numbers, array stuff, just making sure that things work. Okay, and what he does, so we have the public, which is, again, how does he set it up? You have nothing, you load the runtime. And this is the main Wasm, I assume, is the compiled version of the example, right? This is what the compiler
Yeah,
barfs
that's
out.
right.
Okay, good.
Yep.
And then in here we have the exported struct setup, which is basically a function pointer list that you passed Wasm, right? And this is then what's called
Yep.
from the Wasm. Okay, just so I get my basics right. Like I'm a complete Wasm loop. I looked into it a couple of months ago for a minute, and that's about it.
Yeah, I'm not super experienced either. I've just from messing around with this for so long.
Okay, but where's the actual stuff happening? Like, how does this one? This just loads runtime. Where's executable code? Here, we started text decoder. These are all just function definitions and exported. Like, I don't see how things. Oh, here we are.
Yeah,
Initiate
so
streaming.
yeah.
So this. Okay, so we have a fetch call, which basically means this is an async loading of the main Wasm, and then this is where we get. So I don't know
So
the
the
WebAssembly API. Can you?
Yeah, so the important thing here, so it's instantiate streaming, whatever. It's like loading the WASM
Mhm.
module, and the imports here is a predefined thing that I can actually. This might be relevant to look at here. Have you checked out the like Mozilla documentation for WASM instantiate streaming thing?
Six months ago when I
So the second thing passed in the import object is expected to have the env whatever key that you saw.
I'm just const the values to be imported into newly created instance. This is functions represent memory objects. And I assume this one wants. Do they give us any useful? Interestingly, this doesn't mention the env.
Yeah, I noticed that too.
Okay, but in the
I
imports
don't
we
know
have an
how it doesn't.
env, and this is a proxy, so that we can have a getter.
Yeah, so the
Okay.
proxy is not needed, I think.
Okay.
The purpose, and that's actually, I think, makes it slower. The purpose of the proxy, it's basically just passing along the actual data here. So I think the way this is working is if you're getting something called, well, like from their perspective, env dot like callback,
Yeah.
then it'll look into this proxy, right, and
Yeah.
it get the callback thing. And if it the whole purpose of this is for that error at the end, I
Exactly.
think.
This is just to
So
log if you're
right,
missing something instead of crashing with a null pointer exception or something. I
yeah,
guess.
that's
Yeah.
right.
I mean, you're still
So
gonna
that's
fail, but yeah. Okay. Oh no.
so
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 this
that's
returns
how.
is just sorry.
Mhm.
I'm trying to just make sense.
No,
Tell
go
me
on.
if
Yeah.
I'm doing something wrong. But this basically, if you ask for any function that it doesn't know, you return a stub that just logs missing function. That's still probably gonna crash or burn because you might like if this is something that's supposed to return something, you're gonna fail as well. But at least you get a logging when things get called. I'm not sure if I would do it that
Yeah.
way, but I get why it's done. Okay.
The specifics of it, yeah, I'm not sure. I'm guessing it would just be some type of undefined thing happening, some undefined behavior.
Yeah, good question. Yeah, but you could I'd probably log in the getter instead of in the function because if someone asks for something and then it doesn't call it, you don't see the error immediately instead of seeing the error at the invocation side. But again, I don't know. I haven't tried this. Patrick is way more advanced here than I am, so I'm just these are the thoughts that go through my head. Okay, but basically we're proxying exported, so we see, these are the callbacks we set up, and if we forgot anything, we're gonna get this one. That's the whole point of the thing, right?
Yeah, I think so.
Yes. Okay.
Um, yeah, so and that's really kind of all there is to it, I think. If you scroll down though,
Yeah.
does it do anything else in the instantiate? So
We get
that's
some
just
memory.
calling main here. Yeah,
Object instance
allocated.
exports memories allocated, and
Oh,
this is used.
that's
This
some
is just
global.
puts it into global so that then people can, I guess, do something with it. I'll have to look. Sorry, Patrick, we're
Yeah.
totally like uh, stumbling across in your code. If we get anything wrong, just say it in chat and we'll try to correct it. Okay, I'll have to look at. So we get this object instance from the initiate streaming, and for some it has exports memory. Where does this come from? Um,
Yeah, so this is kind of an important thing.
yeah,
So
sure.
exports memory is provided. It's like a memory object, I think, and it's provided by the actual like Wasm instance if you compile it that way. And so this is kind of a question that I don't know the answer to.
Hmm.
And however we're setting this up, there's two ways to do it. When you're actually building your Wasm object, you can do like dash dash import memory.
Yeah.
And I don't, I maybe Patrick can explain the details here better, but one way it's providing the memory for you. And the other way, what you would be doing is actually
What does it mean
instantiating
it
a memory
provides the
object.
memory for you? Who provides what memory for whom?
Yeah, so my understanding, this is why it's so confusing to me too. There's like a memory object that's actually the way it works is it has like a block of memory. So there's a somewhat low level type in JavaScript called something like U8 array or whatever, like a typed array.
Hmm.
And it's just a giant block of memory. And this memory object, I'm pretty sure, just contains a giant typed array. And so it's just some giant block of contiguous memory allocated on the heap.
Hmm.
And that is what's considered your memory for everything you do in
Hmm.
your Wasm code. And
I'm
you can grow
surprised that
it.
it's in X. So
Mhm.
the way again, I have not read any documentation for months, and the things I read months ago I've forgotten mostly. But I would expect, so this is the instance that we just loaded from the WASM file, and the exports would be the
Yeah.
exports that are declared in that WASM file. If the memory is on the exports, it's something that's declared in the WASM file. Is this? But this is now like, is it? Is this an amount of memory that was declared by the WASM file that it needs at runtime, or like, or
No. Yeah. So I think what they mean by instance exports is what's exported by the Wasm
yeah, that's what I mean.
instance.
Yeah.
Yeah. So that's slightly different, at least like in my head, to what's exported by the Wasm file, because I think the Wasm instance has some more like JavaScript weird overhead going on. So like for example, this, right? Like the Wasm instance potentially has this memory block in it.
Hmm.
And so I think that would be considered an export of the
I
Wasm
see.
instance. And
Okay.
it's not necessarily what's needed by the program.
Hmm.
The size of it actually is also configurable at compile time, I think.
Okay.
The initial size and
We'll look
something
at.
like that.
I'm gonna have a. I'm just gonna look at.
Yeah, this
So
may be
we
best.
give it. So the then. So let's look at the return a promise that resolves to a result object, which contains the fields, module, and instance. Okay. Okay. So module is the compile output, and instance is basically our runtime version. That's what I guess from here, but it's all half knowledge. Um, Yeah. So basically, if I use the Docker analogy, this is the container, and this is the no, this is the image, and this is the container. That would be my understanding. So this is the static version. This is the runtime. The
That
R
sounds maybe
concrete version.
right.
Okay, good.
Not
All the
entirely
exported
sure either.
WebAssembly functions that allow calling to WebAssembly from JavaScript. Um, let's see if we can get a description of what's in here. Yes, we understand. That's what you want. Can I get the description of what this does? Returns all objects saying. So this is all super generic with no concrete information.
There is
I
a
get it. This base is based on your website, but it doesn't mention. I thought there would be a special cause. By the way, memory is now blah, but it's not mentioned at
So
all.
yeah, if you click, there's a WebAssembly.memory on the left. That may be better.
Resizable array buffer. So okay, so resizable.
There you
That's also
go.
interesting. Yeah, but this doesn't mention that there is one on the instance. That's what's surprising me. So this is how you would say that you want a new chunk of memory. It doesn't mention.
Yeah, it doesn't provide it on its own. This is the version where you're providing it yourself, I guess.
Yeah. they pass in this. Oh yeah, so you provided us the imports. Where is it? The imports
Yeah.
object here. They pass it in. We don't do that here. Let's see what chat said. You get heap allocated memory configured in link command. I see. Okay, so the WASM contains some information about what kind of memory we want for the instance, and you get it back here. Let's just, without looking too much into it, seems like that's what's happening. If your functions don't need memory and operate on stack only, do you need heap mem? Everything's heap mem, isn't it? Like
Yeah, it is for this. Yeah. It's fake stack.
Fake stack. Okay. Okay. So far, so good. So what we're doing here is we're loading the WASM. We get back the instance. Like I'm going from zero knowledge here, so I have to reiterate. And if someone in chat catches me saying something wrong, etc., just correct me. So this is our now runtime version of the main WASM, including like the exports is going to be all the functions that we export, I assume, plus memory, which was declared at link time that we wanted. So that's why it's here. We can just put in all kinds of log comments and just get something off the ground, just trying to get something running, and then see. But I just want to understand the basic structure. And then on the exports, we have the main function which we exported. We call it with the 0 to have. Give me a second. How is this one declared? Not at all. Why do you pass in 0? Is this the... Oh, because this is... Sure. Let me... Patrick, correct me. I'm just going on a limb. This is our main function, but of course we have program main in Jai. Like, we have something that gets argc and argv.
So
if I go here, give me a second, run support. This one takes an argument counter and a pointer to argv. And what this one does, this call, is just, it calls this, which is the main, and tells it no arguments. And I guess the second one is null by default, or like, why do we get away with not passing a null here? I assume that's the default. Yeah, this is the system entry point. That's exactly what I meant, Patrick. And this is then in sequence calling our program main, which is, oh, you can't see. Well, you can, if you have the stream open as well.
yeah, I just swapped over to stream.
Yeah, then you can, sorry. Since the screen sharing didn't work, just the window sharing, you have to deal with that for now. And this then calls our main, which is the one we defined here. Okay, I get it. Let me have a look at the exported. We have WASM write, WASM debug break, and alert. And I assume that your stubs in here are using that. Let's look at that for a second. Okay, so you declare in your runtime support, you declare a WASM library. And I assume your module, let me just see what it's set up. So you're not using cross-compiling as far as I can see. Oh yeah, you do. So because you're setting CPU target to custom, that immediately means you're in a cross-compiling workspace. That's good. That gives you a lot more capability. And then you set all the options for the target workspace. Okay. And what else are you doing? Oh, and you remap import on runtime support. That awesome. I wasn't certain that you could remap runtime support, but if you can, that's good. Yeah. What else is happening? I don't know what this one does, honestly. I mean, I see this, but I don't know what this means, actually. Oh, is this that every function gets its own section? We'll have to, you know what, let's look it up live. I'm gonna go back to the editor. What does this do in the code? Okay, this We enable stripping. Oh, see, in my tests, Wasm, I have the old version of your plugin checked out, Patrick. So we're gonna update that. That's okay, good. So this was one back from my initial experiments. I just cloned it into tests and wanted to try experiment with it, but this is old. We're gonna update this and use it. But the only thing it does, it sets an LVM option on the target machine, and I don't know what this one does, so we'll have to look up that. Which is, I'm sure it's going to be well documented, etc. It's going to be easy and awesome, as always. Yeah, that's what I thought. I love when I have two keywords in here and the second one just doesn't exist even in the top hit. Emit functions to separate sections. Yeah, that's what I thought. I know that from a certain platform that I can't disclose. So we have to do that for Wasm as well. Okay. Good. So I understand this one. This makes sense. And you add your own modules so that you find the runtime support. Yeah, makes sense as well. I would probably, you could, instead of doing this one, you could probably, by just taking your module path first, you could override any module without having to have a renamed version and having to do remap import. You could just, if you put your own file path, your own modules, like your stub or your replacement file modules as the first element into the array, you would take precedence and you could just override anything that ships with the compiler without having to remap it. But this is more explicit, so maybe that's better. Good question. I don't know. But it has the disadvantage of having to go through the remap mechanism. Well, maybe it doesn't hurt. My attempt would be to just put my own modules in front, and then I can have whatever in here, and it gets loaded first. But this one will work just as fine, and it's more explicit what we're trying to replace. So maybe that's even better. Why is this crap here? Like, honestly, like, what the? By the way, I saw for the first time someone using actually GitHub Copilot live. I watched Andrei Karpathy's stream on GPTs recently, and he codes 80% of what he programs is done by Copilot. It was weird to see. Okay. Are you still there? I guess.
Yeah.
Okay, good. I'm just trying to see if there's anything. So this part is basically from Zoding's plugin, right, Patrick? Like, this is what he did initially. He just removes the body of anything.
So.
So I think I saw this in Zoding's plugin. Is there anything else I need to look at that's special?
Maybe the stack size there.
Yeah, that's
weird.
That's weird, yeah. True.
So that was something that I think I did like a year ago. And it has to do with the way this is relevant here. So when I talked about when you're initializing your memory thing, your memory block, right? You can specify, so this is like your default size, and what happens is when you initialize this, there's an image somewhere that describes this, but you get your giant block of memory, and everything that has to do with the program goes in that giant block of memory. So all of your like, how do I word it? All of your like constants embedded in your executable,
all the globals, etc. Everything. I guess everything in BCC and what is
even
the
like
other
table
one?
lookup things. Everything is in there.
Yeah.
And so there's a couple of things, and so the reason for this is when you call like memory.grow in JavaScript,
Yep.
which is something that my code does, because I had my own allocator implement, like my own kind of bad allocator implemented in actual JavaScript code. And so when you call memory grow, it grows it by a set amount, and I forgot what that amount is, but it grows it by that set amount um, every time, I think.
Yep.
And yeah, and so the only reason for that was to try to get it closer to so that your heap memory is as close to a power of two without going over as possible, I think.
Mhm.
I don't know if the new allocator needs that, but the lot it was kind of important for the logic of my allocator, that's all. And so that's that's just something relevant. And then here also in the link command, you see there's like stack first. They're
Yeah.
putting how does this work? So like when you're writing into stack memory, it goes backwards, I think.
Yeah.
Yeah,
Yeah. Stack is
something like
usually
that.
on the at the end and grows down. Yeah. I'm not sure what
Right. And
stack
so
first
in
changes.
WebAssembly, when you're doing that the other way, so that stack first makes I forgot if it either puts the stack in the other side of the memory or it writes in the opposite direction. But when you don't have that, when you get to the end of your stack memory, it starts overriding like function table methods. So it actually starts writing into like that block of memory. So you can get whatever weird stuff happening you want
Okay.
after when you get to that point. And with stack first, instead of doing that, it just crashes. So that's the goal.
Okay. Let's look at what it actually does. Oh, this is a SIG thing. I don't care. Yeah, I probably have to quote this one because of the dashes. No, the only thing when I look for Wasm and Stack First, the only thing I can find is some
Oh, there's no
SIG
results, huh?
issues, which is uh okay. What we are calling Wasm LD. So let's see if we get any documentation on Wasm LD. Like I don't know why Wasm LD would find something better, but um here we find it. Okay, why can't I just find this when I okay whatever. Search engines are broken. Um, place stack at the
Oh, there you go.
start of linear memory then rather than after the data. Yeah, so this is the place where a visual diagram would be awesome. What do they mean with
Yeah,
after
there
data?
is one.
Okay.
Who knows where though?
WASM 4. Can someone enlighten me? What's WASM 4? Oh, okay. This is a special thing. I thought it was maybe the next standard or something. Um, um, WASM memory layout. Let's see if that's ResearchGate. What? Why is this a what? What? um, if someone has a good reference on this one, I'd love to see it. Um, I just love to see a diagram like how things are usually set up, where the stack is put for WASM, if there's such a thing, or if the stack is outside, or like what the heck. Like obviously, if you grow your stack beyond something, you're gonna override function pointers, etc. That's weird because usually when you let's what do we use? Give me a second. I'm gonna switch to here for a second. I'm gonna use my great mouse drawing skills. As soon as I have something I can show. Okay. So normal memory layout, like call me a noob, but I'll. So if this is mem, okay, this is 0, this is whatever. Whatever you know what? I could use the iPad and the pencil. But before we set that up, like everyone's gonna fall asleep. Normally stack is somewhere here, and it walks down, and here you use regular memory. So at some point, those two are gonna smash into each other, and then if you grow your stack, you're gonna overwrite some of your data. But if you say as soon as the stack grows too big, you override your function table, you said.
Yeah, I think so.
That's weird because I wouldn't expect that to be at the like whatever at the
So
end of your memory. You know what I mean? Like that sounds like data that would
yeah,
be one of the first things you load. So that I don't understand how the stack can smash into your function pointers. That tells me
yeah.
that there's something weird about how Wasm sets up memory. So I'd love to see that before we continue.
So I think the way this is working is, well, yeah, man, I did find when I was working on this like a year ago, I did find a really good image, and I know I'll not be able to find it again. But so I think the way this is working is your heap is the absolute last thing in your memory, which makes sense because when you call like dot grow to your memory and it
Mhm.
increases the whole thing. So that makes sense. And I think typically right before your heap is your stack. And so like your
Ah,
heap
I see.
writing,
Okay,
yeah,
so
from
let me
lowest byte to
try
highest.
to. You're gonna have to deal with the delay, but that means basically what this looks like for WASM is we have a block of memory, okay? Some here, somewhere zero, whatever. It puts the stack here, and then it puts the heap here so that
Yeah,
it can
that's right.
grow. Like if you grow the heap, uh, it can grow the heap without like doing anything else. And then here's whatever your global data, whatever. But that means if your
Hmm.
stack grows in that direction, you're gonna smash into the beginning of your heap.
Well, wait,
Oh
so
no,
this,
or the stack grows down as it usually does, and then
yeah,
you're gonna
that's right.
overwrite your global data. Okay,
Yep.
that's probably the thing. Okay, I see. So the heap goes here, the stack is here, and since the stack grows downward, you're gonna grow into your BSS section and into your like whatever, all your globals.
Yeah.
And that's when bad things happen. So stack first is probably gonna do now the opposite, where you have, if this is again our memory, this is all hypothesis, but like I'm just trying to build hypotheses and then see if that's right, just from what I read. So that would put stack here, which we're still gonna grow downwards. It means if you exceed whatever you set as your stack limit, we saw that for a second here. If we say this is the stack size, then this is what we get here. So this is like our 4 megs or whatever, 4M. Then here is gonna be BSS, etc. And then here is gonna be the heap.
Yep, that sounds right.
um, the rest of the heap, we should say. Um, so if we expand the memory area for some reason, it can grow just okay. And the stack, if we exceed the stack size we specified, we're gonna get memory addresses that are negative, and that's gonna just like fail miserably instead of writing over data. Does that
Yep.
sound about right?
That's the theory here. Yep.
Okay, good. So that's checked off. I don't know what this one means. We'd have to look that up. I don't know what this one means. So this gives us the stack size, allow unfinished, no idea what that means. We can look all of them up. This says we want WASM 64 because otherwise nothing works. And then we give it walloc, which is something that you provide. We'll have to look at where this comes from.
Patrick said no entry means the linker does not look for an entry function. So like that's intuitively obvious to me, but I don't understand why
Yeah,
that matters to WebAssembly in the first place.
exactly.
Because isn't it implied WebAssembly has no entry function,
Yeah,
or am I
exactly.
wrong
So
about that?
I guess there's a default we don't know about. Whoops, that's not what I wanted. Oh,
And I
so
think
there's a
all
default
the rest of these
start. We
options
don't
for
have that.
executing.
So basically, I guess otherwise it would complain that
Oh,
start doesn't exist, and we don't care about start. Um, what's the now we have to look up what's the purpose of start. Is this something that's called when you just load your WASM, or is this like how does start factor into WASM? Because if I look at your code again, the initiate streaming, etc. It's up to me what I do with this one. So there's no built-in like entry point. So I assume, again, just building hypothesis, and you can tell me if I'm wrong, just from how it sounds to me, is that before you get the object file, someone's gonna call your start function if it exists. Correct?
Well, that I don't know. According to Patrick,
Start is the entry point on all
testing
platforms,
did not
normally in
work.
0 to 0A. I see. Okay. The question is, what's the purpose of start in Wasm? Like, who calls into that and when? Or is it just that it just expects it to be there and it's just going to be exported just like anything else, and it's still up to you then to call that? Or like, you know what I mean? Like, why does it matter for Wasm? Okay, but anyway, we ignore the entry point requirements. Which still, like, again, would interest me what its purpose is in Wasm. Like, what happens if you have a start? We have export all. It kind of makes sense, but I'm going to look up everything.
Yeah.
Okay. What's the default, though? Like, if I don't provide that, what's exported? It's maybe for Wasm runtimes outside the browser. That sounds reasonable. What does range do you say? It doesn't, because in Wasm nobody implements it, which is why we need the linker to not look for it. Okay, so yeah, I think Patrick's hypothesis is interesting, that like we are using Wasm in the browser. That's not necessarily the only target. So if you're building a Wasm binary that you then want to run in some sandbox or something, there might be a purpose for a start function, because you don't have this part. Again, this is everything I say is completely unqualified. This is just me making guesses, and then we'll see if it's right. But since you basically, if you say, I don't know, if you want to have the capability to just execute Wasm binaries, then you won't have that part. So maybe that's why it supports it. Whatever, we'll see. Not that important to us right now. What else do we have? Allow undefined. This is legacy flag. Oh, hey Patrick, you're using legacy flags. Unresolved symbols is ignore plus import undefined. Okay, so we look for unresolved symbols. More full feature version of allow undefined. For data and function addresses is trivial. For direct function calls, the link or generated trapping stub function plays without undefined function. Okay. Undefined symbols generated by the assembly imports, including undefined data symbols. This is somewhat similar to import undefined. Okay, I don't know how Wasm relocations work, so I can't make complete sense of this, and I honestly don't wanna. But we might have, like, I might want to look into this later. Okay, and the second thing is, import undefined. This is one. Okay, so allow undefined gives us ignore unresolved and add imports, which is similar to this one. Okay, but it works on all. So it sounds like this might be something we want as well, except for this one. So we might want to try at some point to replace allow undefined with unresolved symbols as import dynamic. Okay, but it just means we need to pick. We can do that anyways. Okay, but this one again means we probably should do it immediately. Can be replaced with import undefined, says Patrick. But then you don't ignore unresolved symbols, right? I'm not sure what's the difference there. But okay, I have a vague understanding that's maybe enough to continue. So let's try to actually make some progress. Like, I have a rough feeling of what's going on. Again, currently we need Wasm 64. We don't have a Wasm 32 path, and I'm not sure how we're gonna get one. Like, I tried back in the days, when I tried, I think it was Soding's plugin, or maybe it was Patrick's plugin, and then with just Soding's 64 to 32 binary, I couldn't get it to work because that just caused type checking errors then. Because we cropped things to 32, but then you had problems with duplicated overloads or something. Like, I couldn't get it to compile after changing the 64 to 32. I got either linker errors or something didn't work. You can tell me if you have any experience with that. But as far as I understand, this is something we need to solve because I don't know what the current state is, but back when I looked into it, again, a couple of months ago, we can check actually when that happened by going to this one and seeing. So yeah, in April. So 6 months is about right. So last time I tried this was 6 months ago. So back then the state was Wasm 64 is basically something you can't deploy because it's behind an experimental feature flag, which means you can't just deploy something to people generally, because no one's going to have that turned on.
Yeah, that sounds right.
Okay. Patrick says he got Wasm 32 working at one point, but it's a nasty hack. You mean the Wasm 64 to 32 in general is a nasty hack? Or you had to have an extra nasty hack on top of that to make it work? Kuyo, have you tried it?
You're talking about the 64 to 32. Yeah, I have that working. Just at exe, yeah.
Okay. No, I mean, have you got it working on your project ever?
What is your question exactly?
Okay,
Like
so
compiling your 64-bit WASM file down to 32-bit WASM file using Soding's thing?
yeah, and then getting that to actually link.
Oh no, I have not tried linking that.
Okay, because my remembers was like this one worked, I think, maybe, I'm not sure, but then I couldn't link it, or maybe this one failed already, like whatever. I had a trivial program and it failed. But since we're here, let's just pull whatever is the current version here. What? Oh, that just needs to be ignored, guys. So I'm just gonna get whatever we had here. Maybe I shouldn't have thrown away my changes, but I assumed that Patrick's is way more advanced than whatever I had. Okay, so I have the current version of Patrick's checked out. So I know it's getting really late for Kuyu, so I'm trying to be fast. I still want to
No, I have plenty of time. Don't worry about it.
Okay. I don't want to be guilty of you missing too
No,
much
it's fine.
sleep or something.
No.
Okay, so if you find you can stay in chat and just help me go through it if in the call. If you want to just drop out, it's also fine. This is the changes by Ian that we're gonna. So this is first things first. I'm just gonna look over the changes and then commit them. This is something that Ian has done as part of a bounty, if I understand correctly. And yeah, I have just an issue with your else style, because that's usually, I know, like the code style of Jai in the modules is a bit all over the place because it was created by different people over many years and we never unified it, but I don't want to make it worse, so I'm trying to have a consistent style going forward at least, and then fixing things whenever I see them. So I don't want to make it worse by just checking in a bunch of stuff that's inconsistent. And if we had done that from the start, we would be in a much better place, code style wise. Yeah, another one. Another one. Maybe I should switch to. I'm gonna share like just for Kuyu's to keep Kuyu sane. I'm gonna switch to what I share with him. I'm gonna switch that to my Vim.
It worked.
Okay, good. More. You know what? I'm gonna want to look at that, all of it, but I could just. How big is this? We're almost through. Okay. Okay. So let's look at what he did. He basically. These are new. Did you extend it up? So there's more going on here than just replacing the x64 versions. Let's turn this one on to make it slightly less of a pain. Okay, so we have two new functions here. I don't know yet why. We'll see. I don't think Ian is in chat, so we can't ask him about these and just hope that they're right. I'm just looking at, again, Kuyu, now you don't see what I'm doing. You're having a hard time.
It's all good. I swapped back to this stream.
Okay. I'm just looking at the diff to see roughly what has changed. Wow, this one blew up. Not sure why. Okay, I don't want to go through all of this. Letter shift right. No, it wasn't. You're lying, Ian. No, sorry, it shouldn't. But it seems okay. So this we can drop because it's not true. It's hard to read. Yeah, this one is tiny, I know, but I don't think I can increase the font size here. Let's see. Nope. Sorry, you have to deal with this being tiny. It's just I'm reviewing the diff. It's not a big deal. I just want to, but there is, holy cow, there's a lot in here. I'm not going to go into that at all, actually. Like, if I try to understand all of this, we're going to waste a bunch of time on the stream right now. So I'm just going to add those two. Where are the Apollo time changes? Here they are. These were relatively tiny. We just have a if CPU fallback. That makes sense. This one surprises me a bit. This one I'm thinking about putting this behind the flag because otherwise we'll pull in the x64 code as well, because this one again is the so if I go back to my editor, like if we have this block in here unconditionally, that means we pull in the ASM again, which we don't want. So I probably do the following. I'll say, do we do it here? Let's do it at the top. Module parameters. We have nothing, and we have compare. What was it? Old. Convert from Apple. And I'm gonna say this is CPU is x64. I'm not sure if this actually compiles because we're using We'll see if that works. And then we can do this one down here and say if compare convert from Apollo implementations. And now we don't have the x64 part in here. I'm currently using Rust plus Bevy. Is Chai similar or is it closer to C++? I have no idea what Bevy is. I haven't programmed in Rust. It's very different from Rust. It's not close to C++ either. So my answer would be no. But I don't want to go into it too much. We're on a mission today, so let's try to roughly stick to that. Okay, so this one is guarded. This one we just threw away. I don't like this style, honestly. Like combining a static if with an asm. Right, I'm gonna do this. Maybe this was like I assume this was in before. I'm gonna change things a bit. Okay, so that's it. There's just this asm code, and that's it. Okay, good. So I'm gonna put those in. Let's see if it compiles. Thanks, Mox. Oh, we already have module parameters and I just didn't see them. No, that's a lie. Oh, damn it, because this is not a module, this is part of basic. So we would have to go here. Yeah, and put this here. Okay, let's try that again. That's no good. That's caused by this one. That was what I was afraid of. We can't use this. Oh, this might work. Nope. This will work, but then we don't test it ever. Is this not, maybe I'm doing this wrong. Give me a second. No, it is CPU. I thought maybe I have a typo in here and then we have a circuit cycle dependency because it can't, like, this should look differently. Like, this shouldn't be here, but I don't want to go into that issue right now. Again, I want to stay on mission, basically. So I'm gonna do this for now, and I'm gonna add a just gonna put in that to do. Just to see if nothing obvious broke. Okay, what happens in chat? Didn't realize Jai was started. Oh yeah, people are doing all kinds of stuff in Jai. You're not using the stream font size. You are correct. Thank you, Mox. Yeah, people don't complain. I don't know. Maybe everyone is running on a 5K display. or no one's looking at chat at the monitor anyways. I'm just background noise so that people don't feel lonely. Could be the... Okay. I have too much crap in here that we're not working on right now. But I don't want to ignore the... you know what? Let's do this for now. Just to weed this out. Okay, so just for today. Okay. There's a very fine line between complaining and pointing things out when you're talking in chat. No, like if I forget to resize my fonts, like if I program off stream, I always reset it to this so I can see more. But I fully understand that this is better for streaming. I just forget, like I'm a professional streamer. Like I forget everything all the time. Forget to set my switch back between code and camera, etc. Like if I forget stuff, please chat, just let me know. Bye, Baker Staunch. Thanks for gifting all the subs and enjoy your board games. Okay, so that was just step 1 of my list. Then I'm just gonna, like, did the tests pass? Nope. Okay. If not okay, possible overloads. Okay, error message on Unary. Let's look at this one. Make something that can fail. Compiler says that... Okay, what do we expect here? So this shouldn't be in regression, it should be in fails. Attempt to use operator is what we expected. We no longer get this. Type 1. Okay, so this actually changed now that we have a not on S64, S128. And we can't really restore that. Because import basic now imports an operator overload. We could do the following. To avoid the import, and then we get the old behavior. That's maybe fine. Yeah, and now we get attempt to use operator on an export of a type that doesn't take this operator. An expression, I mean. Yeah, let's do that. All right. Next thing on my list. Changes in the models forum. So John forwarded me an email by Patrick. So I'm gonna just implement those where I can. I'm gonna read the mail in a second. I'm just gonna do it off stream, of course. I don't want to dox Patrick. So he forwarded it to me. And then he said, I think for atomic compare and swap, we should be able to just use an LVM intrinsic for now. Yes, except that I don't know which one. Honestly, I'm sorry. Okay, so I'm going to go through all the changes that he suggested. Unfortunately, there's no file. It's just a couple of replacements. And we're going to just put them in one by one. Just to get rid of more of the x64 blocks. The more x64 blocks we fill with... So just to explain to people on the stream generally, one of the issues with using Wasm is, of course, Wasm can't take x64 inline assembly. We have things like... this is fine. Oh, wait, where is it in preload? Yeah, it's here. We have this in here. So, and this is preload. This gets compiled into everything. And so if you call anything that takes preload compare and swap, which is everything, because on one-time init is used to initialize the writing to the standard output, etc. You're gonna have an ASM block in your code, and this one doesn't work on anything that's not x64 assembly. So we have in the Wasm plugin that we looked at from Patrick, which is over here, what he does is he just removes the body. Like, this is a hack that Soding originally introduced. You just use the meta program to look at every procedure that gets compiled, and if you find an ASM block in any of it, you're just going to remove the body of that function so that you don't get any ASM blocks in your Wasm, which means you have a bunch of functions that don't contain anything. Like anything that has an ASM block is just going to be completely wiped out, and you in your program have to make sure that you replace these then with functions that are equivalent. This is nasty. It's necessary right now, but it's nasty. So what I want to do as part of this stream, one of the reasons why I want to do this is I want to get rid of as many ASM blocks as we can, so that you don't have to have as many of these hacks whenever you target a non-x64 platform with Jai. This is not just for Wasm. It also it helps with anyone who wants to target an ARM device. That means iOS, Android, Switch, I think, right? And whatever. People are targeting all kinds of weird consoles and console emulators and whatever. And this is always a pain. So the more we get rid of this, is not just for Wasm, it's for pretty much everything. We need to provide fallback for compare and swap. Yes, the problem is, exactly. The problem with compare and swap is a locked comp exchange. I don't know what that looks like on other platforms. I know there is an LVM intrinsic for comp exchange, but I don't know how to do the lock part with an LVM intrinsic. I know very little about x64 assembly. I know just enough. Like, everything I know about x64 assembly, I learned basically while working on a compiler. How does ASM work with LVM? We create inline assembly blocks for this, where we define all the inputs, all the outputs. Like, it's a huge mess. It's slow, it's expensive to compile, I mean. And it's also not quite accurate right now. Like, I think our spill masks are not accurate. So I think we're telling LVM that we're trashing more than we're actually trashing. So it's also not efficient. But it works in LVM by just... like, it's a huge thing. Yeah, this is what's happening. And one of the things we're doing here is we're generating huge strings, which is also really inefficient, but whatever, that tell LVM about outer conditions, and then we feed it in as an inline ASM call, where we give it the constraint, etc. So that's how we pass it to LVM. But it's nothing that will survive non-x64 targets. On non-x64 targets, like, it's just gonna fail. Okay, so what Patrick has done is he provided a bunch of fallbacks that we're gonna try to put in. So I have one for debug break here. That's also in basic, I think. Basic module, if I remember correctly. Nope, wrong. Oh, it might even be in preload. I need to declare a shortcut for doing this. Whatever. Preload. So the version I see here. Interesting, it has different definition. You move this in here. Okay, why not? But now this needs to be a global scope so the compiler can find it. Okay, I'm not sure if this has changed. Because in Patrick's version, this is in here. So maybe this constraint is no longer true. I'm gonna try it and we'll see if it works. But I'm a bit surprised. And then here, we already have an intrinsic fallback. And he has an ARM64 version. I don't think we need that if we have this, right? I think this is fine. I think this is something I added relatively recently, so maybe that's why it's in here. Yeah, we could call it LVM trap. But I think this one is already solved. Okay, one-time init in preload. That's the nasty one we just looked at. And I need something to drink. My voice is getting sore. So I'm gonna take a short pause and get a tea in a minute. But let's look at this one. One-time init. I just removed logic with preload compare and swap and inline asm. So this one says if CPU is x64, and it's uppercase x64, we do this part. Wait, and there's no else? Did I see this correctly? So you just ditch the whole thing? Or am I... That doesn't sound good. That can't work. Like now you're never setting this. LVM trap doesn't work on Android, you say? Interesting. Can I find something about this? That's not English. Of course, I don't see anything. Maybe Google is better. ARM use breakpoint instead of trap to implement debug trap. Okay, but that sounds to me, so this was closed. When was this closed? Closed 2018. So this should be in. So maybe we use debug trap here, and maybe then it's fine. And if it isn't, you have to tell me. Okay. One time init doesn't get called ever when on non-x64. Yeah. My problem with this is now we have a stop here that infinite loops. So I don't like this version. You know what I mean? Like, I'd rather have this. Not sure if we can compile this then. This one is not going to fly because our assert is going to need the init to write, so that's not good. But we can, like, if this doesn't compile, we might do something like set a breakpoint here or something, like calling just failing in some way instead of infinite looping, so that you can at least clearly see what's happening. So you mean one-time init is never called on non-x64 target? That's probably because of your changes, I assume, because everything here calls it. So if you say it doesn't ever get called when on non-x64, I'll need to know why. Because of your changes. Okay, so let's continue. Preload, compare, and swap. Comment out the Wasm block. That's no good. So you also don't have a solution for this. Damn it. I was hoping you did. If CPU is X. I was hoping you have actual solutions to these things. So the problem is I know there's a comp exchange instruction LVM, an intrinsic that I could use, but then it's not locked. So, write string and write strings in runtime support. I provide a non-thread safe alternative to using one-time init because one-time init depends on atomic compare and swap. Yeah, the LVM docs are complete horse crap. Like, they're god awful. Especially for intrinsics. Like, they're so bad. It's embarrassing. And of course, you could say, but LVM is open source. You're supposed to read the source. Yes, but the LVM source is even worse than its documentation. So we have a comp exchange instruction. But I don't know how to make this a locked version. And I don't know, like, maybe this documentation is perfectly fine if you know everything around LVM intrinsics. I don't. So I have trouble turning this into something actionable when I say I want to have the locked version. Kuyuku says atomic RMW.
I really have no idea, though.
What is that? Like,
this was the answer I got from ChatGPT 4. So take that how you will.
oh boy, that's not a good sign. Like, we can try to make sense of the documentation. Yeah, that's wrong. Like I can just see from looking at this that it's wrong because operation can be one of those, and that's not what you're doing. Like we have an exchange here, but we don't have a comp exchange, atomic operation. So no would be my answer. Um, yeah, like you're here in when you do things like that. Um, with ChatGPT, you always have to know like the size of the training data that ChatGPT has seen that might contain the answer. And for anything LVM related, it's roughly zero. So chances of it getting it right are really low. Um,
Thing.
um, and here, yeah, these are not comparing ever. Oh, here we are. Max min, nope. Nope. So that's just plainly wrong. I think so. You can have some. What's success ordering and failure ordering? The problem is I don't know x64 assembly well enough to understand the semantics of this. Like, what does the lock here, like, help me guys, like if there's anyone who has any, like, what does the lock prefix to comp exchange do on x64? Like, how is it different from, I thought comp exchange itself is already atomic. Why do I need a lock? Like, what is this doing? I'm missing context, and I'm missing so much context that I don't even know how to look for it. Like, I can look up comp exchange, but I think I understand just what it does. Yeah, but I don't know why this one would need a lock prefix. And if we look for this one, like we're using this all over the place. If I go to x64 instructions, it's not in here, really? Is this not our x64? What's the file called where we have like the 5 gazillion definitions of x64 instructions? Wasm x64, there it is. There it is. What's the difference between lock and non-lock, and what are we doing? So the difference between this one and this one is that this has GPRM, which means general purpose register or memory, I assume, and this has only memory. So they're different, but I'm so far removed from what this all means that I'm like, I can't make sense of it. Like I maybe I have to just ask Ryan or something. Combat change is not guaranteed to be executed atomically. Oh. But what's the point then of having a non-atomic comp exchange? Like, I don't get it. Yeah, and in LVM it's called atomic. Wait a second. This was part of atomic memory ordering, atomic instructions comp exchange. That to me says this is uninterruptible, isn't it? Like, so it would be fine if we just call comp exchange, right? The problem is, it sounds to me like that's the right thing to do, but I don't know, like, I don't have enough context and knowledge to know how to verify this. If I just put this in as, like, we can just do this. Um, um, oh, yeah. And then declare it as, what's the order here? Pointer compare new. So we would say it takes S32, S32, S32. And then we call it with test old new. And this sounds to me like it should do the right thing, but how on earth am I going to verify that? You know what I mean? Oh, and returns S32, of course. Yeah, so the problem is the difference between, I know that this one, so this says only with lock it's atomic. But I don't understand what the purpose of this one is if it's not atomic. Okay, I guess you save instructions. But yeah, I guess it's just to compare, like, to make it, you have a no branching point in here. Like, okay, I guess I understand why you would do comp exchange without a lock. I get that one now. Now the question to me is, if LVM says this is an atomic operation, it sounds to me like their comp exchange instruction already contains the lock. So we should be fine doing this. Should be right. But again, I don't know how to verify this. Well, actually I do know. We could get rid of this part. Okay. Compile this, something simple for x64, and look at the assembly and see what instruction it barfs out for this one. That should work, right? So what did chat say? The combination instruction will set only if it matches EX, otherwise will jump all 6 up to 6 and restarts the loop. Yeah, but that's just what's written here, right? No, it doesn't. It restarts the loop? What kind of loop, Koraber? Like, what are you talking about? You have to talk to, like, again, if you talk to me about assembly, you have to talk to, like, imagine explaining it to your mother or someone. Yeah, like, this one is good, definitely. Like, this is where I looked up stuff if I want to know anything about x64. The problem is, quite often my knowledge isn't deep enough to fully understand everything that's written here, so it helps me understand things, but I don't grok everything. My feeling from looking at the stuff before is that comp exchange basically never used without lock these days, so it seems like LV has the lock. Can Jai do cross compilation? Yes. Um, yeah, we're gonna test this. Okay, so again, if you want to go to bed at some point, Koyu, just let me know, or just drop off the chat or whatever, like drop off the stream.
Yeah, I'm good for a while. I
Okay,
probably wouldn't anyways for I'd probably be working a couple more hours or something.
okay, because like I'm not, we're now in the weeds of actually before we go to the actual WASM thing, we need to make sure that all of these are correct,
Yeah.
and it's gonna make the WASM thing itself easier because we don't have to like uh like shim so many instructions. So I want to take it slowly instead of just jumping right into WASM and just
Yeah,
flailing around
this
there.
makes a lot of sense to me. Fixing this, especially this method, I think would be
Yeah,
pretty big too.
that would go a long way towards making us nicer on non-x64 targets. Okay, so how do we do this? I'm gonna take the simplest program I can think of. I'm just gonna say main right string over here. Okay. And then I'm gonna just make sure that I'm current. We're gonna use the x6. No, we have to use the LVM target. Else without if. What? What? I can't program. Why am I doing this? I can just do this here and jump here. Thank you. You're a liar. Oh, no, I'm just bad at setting. Really? I'm that bad? Yes, I'm that bad. Okay. Okay. Undefensible architecture x86-64 LVM comp exchange referenced from preload compare and swap. That's no good. Did I? How did I do that? So we didn't find this one. Did I mistype it? I'm like, again, I'm pretty tired. No, that's exactly the same. So I probably got the signature wrong. You know what? I'm gonna take a short break. I'm gonna get a tea, and I'm gonna think about how we do this. It might be that we miss, like it says something about mandatory stuff. Wait a minute, give me a second. But I really need something to drink, like my, I have a sore throat, etc. I'll be back in 5 minutes with a tea and a coffee, and then we'll look at that. Maybe we start from just, wait, we could just write the intermediate representation and compile that to see what comp exchange does, to see if it's the right thing to use. And then we could, if it's the right thing to use, we could still figure out how we have to declare it. And maybe we need a special hack in the LVM backend to add whatever is necessary here. I'll be back in 5 minutes. All right, I'm back with liquids of all kinds. Oh, I forgot the chocolate, damn it. Next time. All right. So Mox might be back. That's good. Shouldn't have done a poll, but a prediction. Yeah. Okay. So I think what I'm gonna try is I'm gonna let's look. I think we have a no split. Yes, output IR. Perfect. So we don't need a meta program. So I just say no split output IR, and maybe do this first. And then let's just look at this one, maybe before optimizations, but it shouldn't matter. Oh, come on, don't be like that. Okay. And then, yeah, that's nonsense. Okay, so we just don't generate the right one here. I wonder why. Maybe because the declaration is wrong. What happened to LVM? Let's do the other one here. Let's just do this and see if and how this one works. Doesn't work either. Wait. I thought we've tried this before. It's considered an LVM intrinsic. Yeah, except that it doesn't work. Test features LVM intrinsics. Okay. Let's try this one and see what it does. So we have to start from first principles here. Let me just quadruple check. Yeah, my Discord stream is still running. I just want to make this as small as possible. The mini text. Okay, let's leave it like this. Do the same with tests, features, LVM intrinsics.jai. Oh, now we get all the errors from preload. So let's change this one. It doesn't work. But we have a test for that. What the heck? This is in tests features. We test everything in features. Run through backend LVM x64. So how does this not compile? Am I going crazy? We have a test that's part of the test suite that executes as part of the test suite successfully, I have to say. And if I now try to compile it, it barfs. Undefined symbol for architecture x86-64 reverse. Makes no sense, right? I just tried that. I just tried it. Here, I just ran it without the extra arcs to make sure. And this is just nothing except that we forced the backend to be LVM. Apart from that, it just runs as part of the regular test suite. No extra arguments. Otherwise, it would look something like this. So, sorry. Something's fishy. Here, it just ran, compiled and ran. Perfectly fine. No complaints. Oh, wait, this is intrinsics. No. We have intrinsics and LVM intrinsics. What does this one do? Oh yeah, that's just, okay, that's fine. No, but LVM intrinsics. Oh, I just saw an ignoring LVM intrinsics warning. Oh, that's from before. No, that's fine. Test smack ignoring. What? So this never ran? Is this a false? Why does it say it doesn't run on this backend? That's not good if that's actually happening. Name backend. Because it only runs on backend. That would explain a lot. Name backend test backend. Okay, let's try that again. LVM intrinsics. So we skip it because we added manually. That's fine. Backend LVM can runs. Oh, okay, this needs to change. Why is this not an enum and then we do it properly? This should never ever happen again. Do we have enums for the backend? I don't think so. Oh, we should have that in compiler at least, right? Well, it's an anonymous backend, anonymous enum. That's not good. Okay, let's be annoying. Do we have a compiler in here? Yes. So we're gonna say backend is type of build options. What was it? Commonly propagated. Oh, we don't even need that. Okay. Let me say backend must be backend. And then we have more backend args around. So this would be LVM. Holy cow that we have that kind of bug. Not 45, x64, LVM. And otherwise it's, oh, we can't do that. Okay, we have to use our own version of that. Because we want to have the all backends option, which doesn't exist in the other enum. Okay. Adjust for backend. What does this do? Oh, this is gonna take a while. What's the sound effects packet for me? Is it and deep breathing into the mic, or what's my sound effect packet gonna look like? Chewing into the microphone. So this is LVM, backend is LVM, all backends is let's just define this in here. Oh, we can just call this all, by the way, just so we can do another round of changes. Okay. Compile and run tests. Backend. Or yeah, tests backend. Yeah, that needs to change. If test backend is x64, else if test backend is LVM. You know what? get all test files in here for this particular backend, just for backend. Okay. Run one test program, test backend isn't 0. Backend. So this has nothing to do with LVM, but just fixing stuff that's broken out of tests, which is way more important. Nothing to do with, nothing with Wasm, sorry. Okay, so if test backend and not test backend and backend, ignoring blah for backend, blah, because it only runs on backend, blah. Okay, that should still work. Yeah, otherwise we do it separately, and this is now x64. Come on. Adjust for backend, we get a backend, test backend is blah. Ah, I see. Yeah, this is perfectly fine. This is just, we have this feature of having tests that depend on other tests, like not depend, but making sure that certain tests don't run in parallel. That's the signal and wait for signal. And if we have multiple backend, if we try the x64 and the LVM version, we have to make sure that the x64 version waits for the signal from the x64 version, and the LVM version waits for the signal from the LVM version. So that's what this one does. That's fine. Okay, this might compile. And if it does, okay, except I can't type, of course, but that's nothing new. Regulars of the stream expect me to mess up the typing, I guess. Okay. And now we'll have a sad awakening. Also, this is interesting, but I'm not going to go into it right now. But maybe I want to keep it around. As remembrance, we might have a like flaky test. Yeah, surprise, doesn't work. Damn it. God damn it. Also interesting, that means this was our only backend specific test we have left. Right? This is the only test that uses backend. So that's why we didn't realize this. Fun. Okay. So our whole intrinsic code is broken. Okay, let's see why. Because that's kind of important. Return the LVM intrinsic name that starts with LVM dot as stored in elsewhere information exported name. Users must declare this for it to work. Okay. Yeah, you can now use LVM intrinsics directly. That was a lie and no one realized. Interesting. So how are we using this? And then we return LVM dot, which I also don't like. So this is an LVM intrinsic. And then we make sure that it's only, let's see if we hit this one. If we do the one that failed, and this one now fails reliably, which is also interesting. Okay, I'll have to look at that. For now, we just do this. If I say x64, do we get the error message? Yeah, except that I can't do this. Okay. And parameters can only be called within the LVM backend. Good. So this check runs, which means it's going to be the lambda's intrinsic flag is set, and we recognize that it's an LVM intrinsic. That's good. Now the question is, so we do something here as well. Messy hack, and may want to do it more carefully. Okay, yeah, no, that's fine. So the question is, why are we not handling this properly in the LVM backend then? It worked a while back. Yeah, we can check when it stopped working, of course, if we know it worked. Like if we go to the change log, April, so it supposedly worked in April. Shall we do it by sect and see when it barfed? Maybe that will help us figuring out what's going on. Okay. Vip fix that tests we never actually ran the. Okay, then these changes we're just gonna stash for now until we fix that. Okay. So we're up to date, right? Yeah. Sect. No, before we do git bisect start. Whatever. Git bisect. This is definitely bad. But now let's go back to where we did the. So supposedly, yeah, fixed the new LLM intrinsic. We're not working on Unix. So supposedly in 160 they seem to really have worked. April 8th. So let's go back there. April 9th, April 7th, so somewhere here. Update the version number from beta, it's not changing for the new beta. So this one should be good. It's gonna take a while. We did a couple of LVM migrations between that, I think, which is one of the things that might have broken this. So, okay, let's do a full test. So we do this plus this to get a test. Yikes, what was happening there? Okay, that's fine. That's all fine. That shouldn't impede our test. Unable open file for reading. What? So we didn't have that test back then? Or was it just named differently? That's an interesting thing to check. If we go here, I didn't touch it here. Here we... do I have to go back here now just to see when that file changed? Can I do git log this one? Does it go? We want master. Yeah, so I added the test. Awesome. April 13th and fixed them on Unix. So supposedly, so which commit is this? Supposedly they worked here. Let's see if that's true. If not, I know who's to blame. What am I doing? Asks MBMB Granite Large. Initially we tried to get Wasm to work, but now we're like from there 3 layers deep of fixing stuff. So this compiled, interestingly. So back here it worked. I want to verify by doing, I'm not sure if we had emit IR, etc. at this, probably not. I think I added them later. Yeah. Let's run this one. Yeah, worked. Okay, git bisect, good. That's at least, I mean, that's good. That means we're gonna find out when this broke. Relatively quickly as well. Okay, so this takes a while to check out. I bet there was an LVM upgrade in the midst. If it's bad now, chances are very high that this broke with an LVM upgrade. And then, yeah, we'll have to see. It's not gonna be fun. Getting strong. LVM is to blame. The upgrade is to blame. Vibes here. Might be wrong. It's a bit early to tell. Git bisect is so useful for these kinds of things. Something broke 8 months ago or 6 months ago. Like, it's not fun to figure that out otherwise. This is good. This is bad. This is good. I wouldn't describe it as fun, but it's super useful. Honing in on the problem. This is a body. this is a goodie. So it was me. More thorough fix for don't create more than one debug info. First bad commit. Okay. What did I do? What are we doing? Man, so this is not that long ago. 4 months. No, 2 months. 3 months. I'm using the new GC MVP, decompile a small language to Wasm, and it's so easy and convenient to not have to bring my own malloc. I have no idea what you're talking about. What's a GC MVP? Okay, so what am I doing? I removed outputted object file names and global procedures to export list and non-constant declaration exports and merged that. So basically I added, so the path is this one, I think. And we have globals and lambdas now as well. Okay, so what happened? So AST list is what's now called globals. Where's AST lists? I didn't throw this one away. Converter AST lists 0. What's AST lists? Does this still exist? But I didn't throw this one away. Maybe we threw it away later. But I didn't discard this one. So we have to check if this one is still needs to be around because we're not adding to it anymore. I vaguely remember this change. Oh yeah, and I remember, yeah, this was for console fix. So we're doing this now conditionally. If we have a function, okay. Just seeing if I broke this just by accident because I dropped something. What does what code do? This one? Yeah, this basically, the LVM backend generates, like feeds the LVM API with information to basically generate the LVM IR. But not actually generating the LVM IR except for in memory in LVM. So the difference I see here is we always get the final declaration, not just for S declarations. because the globals list only contains declarations, I guess. So it could be that this one is the trouble, that we're creating all of them without. Maybe we should check if it's not an intrinsic or something like this. I assume that this now breaks. So it's very likely that we do this to that this somehow like short circuits the check for an intrinsic because we already have a function or something. It's most likely that something like this makes it barf. Okay. I'm gonna flag this one. And I'm gonna go back to where we were. Okay, is it not a board? Reset, I guess, right? I thought it was, no, it is a board. No, it is reset. Okay. So we're in the LVM converter. Do we still have this AST lists? Yes. Does it still, is it used ever? No. So I forgot to clean this up. Done. So we fixed something as well. Like we cleaned something up as well. I mean, okay, this one. Where do we do the intrinsic check? What else are we doing with intrinsics here? We only have those two checks in here. So what changed about this? And this is not reprod. Who typed this? Probably me, but I can't remember if this is my, I don't think this was my comment. Are we generating garbage LVMAR? Yeah, kinda. Like we're not marking this as an intrinsic. We can actually, if we go back to the bad one, like to this one, I'm interested in what the EIR looks like. So I'm gonna go to default meta program, and I'm just gonna say options, LVM options, emit IR something. No, what's it called? Output LVMIR. And we're gonna say split modules is false. Okay, and now we're trying to compile this test again. Because I want to see what this looks like. lazy. I don't want to look for that file in this huge folder, so I'm going to delete that folder. So we now have just one thing here. Yes, this is going to be large maybe. We are looking for bit reverse. So we just say call bit reverse blah. We declare it as this. Okay. And if I go one up, do the same thing. Both, Patrick, like I have textual and I have jails, not fully set up, but I have jails actually. Okay, bit reverse is now no longer here. What? Are you kidding me? Where's main? How can it be not here at all? It's not in here anymore. How did it look before and how does it look now? Yeah, sorry, Kuyu, for wasting your time because we found something else, but we can't actually proceed before we have fixed this. If you're still here.
Yeah, this is fine. I don't mind.
Okay. So where's the call? We call reverse. We just say call reverse and that's it on the bytecode level. Nothing has changed, I guess, with regards to that. Yes, that's Kuyu. I think. Or it's a pretender. Okay, so we have to find the actual main. Here's program main. Call. No, that's just debug information. Debug information. What the heck? What is the complaint? It says it can't find reverse. So here we just now call reverse. How can that happen? So we don't even use the LVM name. Maybe a debugger is a better idea in this at this point. So here we're doing the wrong thing now. Create LVM function. It should be elsewhere, probably, because none of this changed. I'm gonna do the following. So this is what changed definitely, right? We're now doing this. We have a pre-pass now. Why am I having a hard time reasoning about this? So what has changed is that we're doing a pre-pass as far as I remember. So we now have get LVM function and create LVM function. So I split this apart because we have a pre-pass somewhere. Let's see if I can find it. Oh. Guys. Do you see that? That's kind of bad, isn't it? This is the problem. I should have seen this on the first pass. I dropped this one on the floor, and this is exactly the problem. We have to now do this when we do the pre-pass. If we generate the intrinsics during the pre-pass, which I'll see in a moment. Create all LVM functions up front. Yeah. So here we would have to do the... I'm stupid. I should have seen this earlier. Okay, but that's the problem. That's exactly the problem. So we can go back to where we are. I'm going to ramp up Xcode. It's going to take a while till this is here. Let's leave this one on so we can verify, but it shouldn't be necessary. I'm going to set a breakpoint here as soon as Xcode finally has finished doing something. We don't need this anymore. Good. So we want to run tests. What is that lovely thing called? Test features. LVM intrinsics. That's the only one. Okay. We don't want the x64 backend for obvious reasons. We're going to go to the LVM converter. Set a breakpoint here. Yeah, by the way, Kuyu, congrats on the trailer. It's really well made.
Yeah, thanks. That took so incredibly long.
let's do a shout out to Kuyu. So A, is it? Do you do it like this? And number 2, let's show your trailer to people who are not in the secret beta. If I can find it in a damn spammy showcase. Like, I hate real-time chat
also,
so
if that's easier.
I'm not sure. Give me a second. Goblin something. No, it's Fat.
Fat Goblins.
There's the trailer. So let's just go to the Steam page. This is the guy whose voice you hear. He did this one. I can't hear the sound here, unfortunately, which is bad because it's one of the best things about the trailer. Can you guys hear it? Because I can't. Anyways, this is his game. The trailer looks awesome, like really well made, etc. Give it a try. Have a look.
Thanks. You know what's interesting is it's a 32 player game, right?
Yeah.
And so I didn't want to coordinate 32 players to make the trailer. So I have a little script that like intercepts packets and records scenes and sends back the packets, and it simulates like a bunch of fake players. So all this stuff was made with like 4 friends. And we just
nice.
recorded the same exact scene like 8 times in a row.
And then you just overlapped all the player interactions or what?
Yeah, so everything is just like the history of us playing. Yeah,
Nice.
it worked kind of well. It was really buggy, but kind of worked.
So yeah, like huge respect for getting this done. This is written in Jai, right?
Yeah, that's right.
Yeah,
Everything is
complete
dry,
game
and
is in
it's
Jai,
custom
looks
physics, custom
awesome.
graphics.
So wishlist this, whatever. Do what you have to do to remember this, or just look at the
Yeah,
trailer
that's.
with sound. For some reason, I don't have sound here. I don't know why.
I
Sucks.
appreciate the shout out.
Yeah, it's just a couple of people. Most are probably in the beta, but still, if someone discovers it, it's worth it.
Yeah, true.
Okay, so we do it in the intrinsic, so we don't see the intrinsic in the pre-pass. Okay, that's interesting to know as well. So over here, we just need to do the thing that we dropped on the floor because I don't know why. No, not store steam powered. Damn it! Now I forgot. I overwrote my buffer. So this was in. Nope. I don't want to search here. I want to search. Go to broken, my friend. Now I want to search in the diff here. That should be yes. So I dropped the intrinsic name argument here for stupidity reasons. And we do get LVM function. We did get LVM function with an intrinsic name, and we said name intrinsic name. Okay, so it overrode the linkage name. That shouldn't be hard. And I dropped it where? Here. So I'm gonna say we're gonna check this flag if it is gonna do that. So we go to the LVM converter. I'm gonna go to create LVM function. And we're gonna do the following. We need to get the defen. The defen is God, why do I have a hard time remembering this? This should be on inferred type, right? Or is it linked here directly? But we have the defen flags right here, so we can just check this one. If lambda defen flags is intrinsic, then we check is LVM intrinsic. We should have an intrinsic name. If we have an intrinsic name, so we say character, I think, right? Get linkage name returns a character, yeah. We do this, and also that means we can drop the initialization. Okay, let's leave this one. And now this should help us. Oh no, right. We shouldn't create that function because if we look at the old code, we put the intrinsic name into get LVM function, and then we use that to look up the function. And I assume with the LVM intrinsic name, we always get something back, but I actually don't know. But if we look, the intrinsic name is never used during create. So it must be that it's that it happens here. And we'll just set a breakpoint here to see if it ever happens. So I'm going to compile this version. And in create, we're going to set a breakpoint. And we're going to set a breakpoint here. And then we'll just see what happens. Like the only, like going back to the trailer, the only slight critique I'd have is it's been like a while before, since I watched it, but I think it should be like the beginning is probably too long for the TikTok generation. Like you might lose people before the fun starts because it's such a ramp up before you see what's going on. You know what I mean?
Yeah, I do agree with that. It was actually quite a bit longer, and the goal was always to cut it down. So yeah, and it was there. I felt like there's no good solution there.
Yeah.
Like
If you want to build up
yeah,
like the thing, you need to be
right, yeah, it
being
has that purpose, and
yeah.
so the compromise is hard. I do agree though. I don't know what I feel like it definitely could be improved in some ways. And I spent like no money at all on it. So if I actually, invested something in it, I wonder how I'm always curious what changes would have been made.
Yeah. Yeah.
But yeah, I do see that. No clue what to do about it.
I can't give you like I've never made a trailer for a game. I've never made a game of this scope, so I can't tell you anything about this. But just I had the feeling like you're probably gonna lose a bunch of the younger people who are used to being captured within 5 seconds. Like you can
Yeah, I
even
know.
see
It's
this
tough.
nowadays,
Honestly,
like with
right. I
the
think I suck at that like audience and marketing. I think I'm horrible. And that's like the main audience now, right? Like
yeah,
so I am yeah, I have no clue what to do there.
yeah,
I think
me
that's
neither.
definitely something I'm bad at, right? Yeah.
You can't the problem is nowadays you have to be so good at so many things. I don't know how you're supposed to do this as a single person.
It feels like I need some Zoomer friends I can
Yeah,
get some advice from.
yeah, hang around at the swing at the local park, like the swing and the seesaw, and just try to be friends and people. I'm sure it's gonna go
Hey,
well.
you want to check out this trailer on my phone?
Yeah. Okay, so the problem I have right now, I can't. Maybe I just need to go back to the original broken before the broken commit to get or create and see what happens. It's hard to see from the diff. So we use the intrinsic name. It seems like we don't ever get the function. Like it doesn't exist initially. I thought maybe the module has all the intrinsics predefined, and then you just said you actually get it from initially, like from the start. That doesn't seem to be what's happening. Instead, okay, so we put the name there, so we don't do it twice, and then we just create it. Okay. All right, then let's try that. So I'm gonna go back to the master, put this in again. So we have to do this intrinsic name stuff twice. Feels a bit meh. We could have the out name argument again. It feels messy, but having it twice feels messy as well. But I think we need it twice because if you just call create, you still need this to be happening. So maybe we do a actually, you know what? Like we can just put this and get linkage name and be done with it. Right? Except that nope, that's called too much. Static character get LVM linkage name or intrinsic name. How about that? Isn't that a lovely name for a function? But I don't want to have this lying around twice. And we need the as lambda, and that's about it. Oh, we need the interp as well. So let's just use the interp. Workspace. I don't know why we need the workspace though. Ugh, okay, yeah. Lots happening in there. And then this one just becomes get LVM, link at your intrinsic name, helper interp, lambda. Boy, we're doing it twice now, which is not ideal, but it's also not terrible. Okay, make that compile. You had to follow when you saw NVim? Really interesting. You shouldn't hear me talking about NVim then. But hi, welcome to the channel, Mr. Handless. This compiles now, hooray! Let's clean up this stuff. Ooh, nice render error. So this can go away. This is fine, and we fix a very old regression. And now we just merge those three VIP. Damn it, undo. Where's which commit broke it? 22212. Okay, I want to reference that. So no, actually, fix up, reword. Fixed element intrinsic regression in 22212. I said. Damn it, my memory is so bad recently, especially when streaming. Takes an action. I ran that intrinsics test. Okay, and now we just need to check if I remember that correctly for 5 seconds, which seems to be hard for me. And I talk about the attention span of the new generation, huh? 22212. Okay, I got it right. Good. I'm just insecure. So now we can go back to what we actually wanted to do, which is the Wasm stuff. Let's test everything, then let's unstash our Wasm changes, test them. Just wanna like baby steps. Let's see if this one actually calls the LVM intrinsics tests now. Oh damn it, I should have cleaned my, not adding already added. Okay, good. So it is part of the queue now. And it was compiled, and it is running, and we're happy. Hooray! Okay, let's go one level further up. We had these changes to preload, and we tried LVM comp exchange. And what I actually wanted to do is try them now on the x64 target. Man, like now we like going back up the stack through all the things we actually wanted to do. So what we wanted to do is we wanted to check if comp exchange does a locked, like compiles to locked comp exchange, just so that we're certain. And that we're certain that this uses the right instruction, at least on x64. So we're gonna do jai, I think I call it simple.jai, and we said no split. You know what? I can just look this up in my buffer. Yes, output IR. And we couldn't find LVM comp exchange. At least we now use the right name. But the problem is probably that we're not using the right suffix. If we look at where we did, man, my youngest one has a cough. That's not funny. Do you call it cough? Cough? Cough, probably, right? So I think we have to do the size back here. Let's try that again. Ah, don't be like that. What am I doing wrong? Let's look at the intermediate representation. Cough. So just like the file format. At least just like I pronounce the file format, I should say. So we say call LVM comp exchange. And that doesn't go well. Okay, why though? If we look here, yeah, the problem is it's not here. It's not mentioned as a call. It's literally a comp exchange. What about the other intrinsic we're using? This is bit reverse. Is this mentioned anywhere? Bit reverse. Bit manipulation intrinsics. These are called LVM bit reverse dot star. See? Okay, so they are. They're declared like that. Okay, let's compare that to how comp exchange is declared. I want to have that one. That's literally a so that's a special instruction. That's not an intrinsic. I didn't realize the difference. So this is an intrinsic. This is an instruction. So what do we do about that? Do we add a special case for this one into the LVM backend where we say if we're trying to call LVM comp exchange, then actually do this instruction? I'll have to think about that. Short break again. I'm gonna get another coffee and tea probably. And we have to think about how we do the generation. So what we actually need to do here, instead of just treating it as an intrinsic as we did before, if we go to the LVM converter, yeah, maybe this is not good to have this as call procedure. But here we would have to do something like IR builder. We have to find the thing on the IR builder that gives us the comp exchange. Let's see, do I still have the LVM source code here? LVM 16. Are we on 16 right now? Okay. I thought we made the jump to 17. Probably not because it was too slow. I think we tried 17. Maybe it wasn't out last time we upgraded. Can't remember. Whatever. Not important. So I have to find the IR builder, which would be under include. You know what? No, let's go macOS release include LVM IR builder. There we are. And we have create atomic comp exchange, which takes 3 values. So we might have here, where was it? That's not what I wanted. Here, have a special case where we say, if you're trying to call comp exchange, we're gonna unwrap it and just call comp exchange, which would be a special hack for this particular one. The other way to do this would be to add a bytecode instruction and have our own intrinsic, like introduce an intrinsic just like memcopy, and say either like that would be the clean way to do it. Do we have this still open somewhere? I have so much crap open. And just say here that we're using the intrinsic comp exchange instead of doing the inline x64, and then either turning this bytecode instruction into a comp exchange in the LVM converter, or in the x64 converter, just creating this locked comp exchange. That would be the clean way to do it. But it would mean introducing a new bytecode instruction just for this, which feels not sure if that's a good idea. So the way to do this would be, let me look this up. I wanted to take a break, but I want to look this up first so that I can then link about it. So here we have these, okay? And now the clean, in quotes, way would be to do this. And then just as we do memcopy and etc., also have a special case for comp exchange in the compiler that then converts this code to either the LVM instruction or this assembly. Maybe we do that. I have to look at how we implement these intrinsics to see how much of a mess it creates. Maybe that's a clean one, but I need a short break. I'll be back in a couple of minutes. All right, I'm back. What happened? Yeah, the preload code is something that gets loaded into every workspace, and it contains the initial definitions that you need to compile pretty much anything else. Okay, so I think I'm going to go with this approach. It feels better. I have to look at how we do the intrinsics memcopy, if they're separate bytecode instructions or if there's one intrinsic instruction that maps to all of them. I think it's the former, but I'm not completely sure. So if we go to bytecode builder, and just look for instruction memcopy sized. Memcopy, memcompare. These are all of these, right? Memset. Yeah, so we have separate instructions for all of them. I think it's still the right thing to do. So we're gonna go to byte instructions, memset, memcopy. Where's the other intrinsic? Oh, so these are using the same memcopies. No. Interesting. So we have bytecode memcopy, and then we have intrinsic memcompare, intrinsic memset. Kuyuku says he's not certain that this would work for Wasm. If memcopy is an intrinsic that gets called as an exported function. We'll look at that. I'm trying to get the comp exchange working, and then we'll look at the rest. So I think I add this here. Locked comp exchange, and we need 3 values, no size. Maybe do we need the size? If we go to the builder, like, do we have different versions per size? Let's just, for right now, I'm just going to use the times 32 version because we only need that, I think. Might be wrong. Let's see. If I look for this one. So they map to the same, but this is pointer version. So this is 64. So we need both. Who else does something? But it means we need both a 64 and a 32-bit version. So I guess we need the size. So we would have both here. Or do we just make this a pointer version? I'm not sure. Oh, that's my T timer. Yeah, let's just take those two and then do the casting where we need it. Okay, if we have this, suppose we have this, so I think we'll have a size that's just, how do we do this normally? We have a size, clear memory sized. Seems overkill. I would just want to see if I just want to like keep track of the size of the operation. Maybe that's not necessary because the value, how do we do this normally? Okay, I'm gonna flail at this until it works in classic fashion for the stream. So we have locked comp exchange. We have RAB. Maybe we should say old, new. No, new. Damn it. Curse you, C++. New is a keyword. Old value. New value. Better. And with this one, we'll have, we put it after memset, right? So memset, compare are in the other order. So I'm gonna flip them here as well. Fingers. If they're here as memset, memcompare, I want to have them here as memset, memcompare, and then I want to have comp exchange, value number result, value number, old value, value number, new value, no size, and we want the line number. Okay, so this is locked. So we have result, we have old value, we have new value, and this is of course the same on both sides. And then we say we have write access to result and two read accesses. Okay, that doesn't exist, of course, because this is C++. We have the great pleasure of doing everything twice. Oops. I hate this language. Seriously. Okay, so we will say, where do we do this one? Intrinsic locked CMP exchange, locked CMP exchange. Okay, I guess we do it like this. That's number one. Then we just have this one where we do the comparisons. So we do memcopy mem set, mem compare, and then now fresh off the presses, locked, or how do we call it actually? Lock comp exchange. So I should also call this not locked, but lock comp exchange, just to be consistent. So this is lock, which means we go to Python instructions and have to change this again. So we expect 3 arguments. No, we expect wait a second. I expect 3 arguments and the return register. Here we say AB count, and here this will be old value. Old value register. No, actually this will be wait, I'm doing, yeah, okay. Pointer register. Old value register. New value register. And we get a result register. And we do instruction lock comp exchange, result register, pointer register, old value register, and new value register. And I messed this one up because it means we need 1 extra argument. Hooray, let's go back. So we have value number pointer. Hooray. So I have to go here and say value number pointer, and that's actually not true. That's just red. Right? Should we mark this as red, right? Actually, I don't know. No, because the pointer is just red. We write to the address of the pointer, but the pointer itself is just red. I think this is right. So we have result, pointer, old, new, and the line. Oh, and because this is C++, we can do it twice again, because it's so much fun. The change. Okay, so that gives us the instruction. We save the data for the instruction. Now we have to implement it, which means we have to go to everyone who does mem compare and do now our version. So LVM says for lock CMP exchange. Lock CMP XG blah 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 blah. we need pointer, pointer, pointer type, pointer, old value type, old value, new value type, new value, blah blah blah. I'm doing this very mechanistic. Some of these things might be wrong. I load the pointer, I load this, I load this. Seems right so far. But it might not be. This is pointer type. Oh, we know that this is always going to be pointer, actually. Whatever. But I don't want to go into this right now, so I'm just going to do it mechanistically, and then we clean it up. New value type gets new value, blah, and then instead of creating call, etc., we're going to say the thing we just looked up, which is create atomic comp exchange instruction. Which gives us an instruction. And then we have to get the alignment stuff right, etc., etc. So we say IR builder, create atomic comp exchange with pointer, old value, new value. Do we have defaults for the rest? Maybe align, success ordering, failure ordering. None of them have defaults. So the maybe align. Let me look up. How we normally do the alignment stuff. Because I don't know. Maybe align 1. Okay. I don't know how we know what the right alignment is. I'm gonna do this, but and then the other ones, which is success ordering and failure ordering. How does computer synchronize with other atomic operations? I don't know. If someone knows, let me know. Otherwise, I'm just gonna give. What are these? Okay. Semantic support from Java and C++. Awesome. Determining which other atomic instructions on the same address they synchronize with. More There's no guarantee that the modification orders can be combined. Reads the value name of code immediately before the value it writes. Yeah, okay. Is there anyone in chat that's still awake that knows the C++ stuff well enough to know if we need acquire relate, acquire release or not? They just basically defer to the C++ semantics, which isn't fun. Because if we get this wrong, we might get very subtle issues. Comp exchange, essentially like an atomic load followed by an atomic store, but no other memory operations can happen on any thread between the load and store. That's fine. That's all we need, isn't it? Like a fence. It's normally used along with monatomic memory operation. It's roughly equivalent to release store sequence. I don't think that matters for our purpose. If I understand it correctly, we should be fine with monotonic. I don't know how to prove that though. But since I'm gonna go with that for now. So how do we get atomic ordering? Is this an enum? It's a class. It's an enum class. Okay, awesome. So we just say atomic ordering monotonic, I guess. Give me a second. Okay. So let's go back to this one so that I can hear Koyo if he has to say anything. So this was atomic ordering. Monotonic atomic ordering. And that gives us this instruction. How do I now get the... God, we have too much crap open. Where's my mouse? Can I have my mouse, please? Thank you. So I get a value back. So we just call this result, I guess. And then just we store from result to the R register here. That might work. So this is number one. This needs to happen. I think this is the return check, right? Oh, bytecodes match. Okay. This is in the runner. That's gonna be... what do we do in the runner? What the heck do we do in the runner? How do I do the locked comp exchange at compile time? Like, how do I specify the same thing now in C++, basically? And here I don't know as which ones I should load these. That's something we need to figure out. Man, this is work. Okay, now the question, yeah, how do I do this in C++ now? That's the big question. I could emulate it by making, like, if I can't figure it out easily, I could emulate it by just creating an Wasm block and executing that. So I could just basically do this and pretend that we had basically this part, just doing what this would do in here. Oops, I didn't want to have this that often. And I need to figure out how I know the size if I just use the... I'll have to think about that. Let's look at the other ones. BC debugger, that's easy. Pointer, old value, new value. And that's the result value, I guess. This one we did already, and it's wrong. Good that I looked at it again, because we need to map all four. Okay. And then we have this one. Wait. Why do we have this twice here? This is the name. How do we print this? I think we just do commas. So we say pointer A, B. I know AB is of course wrong. This is old value, new value. So this is for dumping. That's done. I still need to know the size. What kind of bytecode instructions do we have that have variable size? I guess any add. So I could look at like bytecode add or something, how it determines the size. And then this one still needs to happen. Bytecode intrinsic lock. And here we just put in whatever is necessary to encode that instruction. I actually don't know. I'll just put a big to do here. And then we go back and do the rest. Assert false for now. Okay. With that, let's go back to this one and compare with, what's the default instruction? Like bin up, I guess. See, run math bin up. How do we know the size of each one? Okay. So we get the value type Okay. So we know the type by saying get value type. So we would have to do here something like this. And old and new must be the same. So now with this one, we know the flags. And then we can do the different versions based on the size. So type and subscript. Okay. Okay, I still need to figure out how we do this at compile time. What does this look like in C++? Like, how would I specify this one in C++? Do I have to do std atomic? That would be awful. Do we ever do this actually? So we have atomic exchange. So we have this one. Nice. But this is just for 64-bit. I guess we'd have to version for 32-bit and then maybe just assert on all the others. We have to be careful because it's flipped. Wait, why are these pointers? Oh, never mind, because it's this. And then let's do this again. Maybe the bool version is easier because I don't have to replace all the pointers. And now we can use this here and say if number flags and something something number flags number flag 64-bit then we do we have the pointer, right? Yes. And we want so maybe we do also the macro version, like the do it. Let's do it by hand for now. So I say old value is S64, no, atomic compare and change, new value, old value. And we just say result. And then we say this is result S64 is 64 result. F is number flags, number flag 32-bit, and then the rest is just not implemented yet for now. Oh, give me a second. We had something about pointer before. What was this? Bin up. We had a 0. These are pointers. Let's just say here, assert false. And we say interp is unhandled. Size for block. Something like this. And we should maybe have a site, I don't know. Okay. And now here we just say S32 without any casts. Now we could just copy this for 16 and 8 bits, etc. But I'm not gonna for now. What else? There were more things that I punted on. This is fine. These are all fine. This one is not fine. So the x64 backend doesn't know how to do it yet. I would just need to figure out how this is encoded in x64 and output the byte sequence. I'm not sure if we have that right now. It is in the, like, obviously the inline assembly part can do this. It's not easy. Like, that code is optimized for conciseness and speed. So I can't. I just can't figure it out from there. I'm not sure how we're gonna do this, but let's just not worry about the x64 backend for now. Let's just make this work. What did it complain about? Memory named intrinsic, yeah. But also, I forgot these. Okay. No matching call. No known conversion from character pointer to void volatile for first argument. Now it will complain up here. No. This is lock comp exchange. This is lock comp exchange. This is all wrong. This one would have been, well, no, it would have just not compiled, so it's fine. Next one, atomic exchange. Cannot convert an argument of incomplete type. Of incomplete type void star? What? What? Oh, damn it. Yeah, we don't have a site. What we use as a site. I think we have on the bytecode. We have a debug expression. Okay, let's set that. Let's use that. I'm not sure if it's always set, but for now it should be good enough. This is of course nonsense, but we don't need it anymore. The atomic compare exchange it couldn't find, so I missed it for someone. Compare exchange. This is S32 volatile desk pointer. Okay. Still, which one couldn't we find? Void pointer int referenced from blah. Because this one. Or do we just... No, let's just change the definition of this one, I guess. No, it is a bool pointer, so this should be a S32 pointer, yes. How did I define it? Here it's an S32 pointer. Okay, never mind. It's fine. I just messed up some of the definitions. This should be S32 pointer. This is S32 pointer. Anyone else? Nope. No matching function call again. Yeah. Can I just do this? S32 volatile pointer lux. I have this one wrong. This is not an S32 pointer. Maybe that was the problem. Ooh. That looks good. Okay, we have something that compiles. It's still completely broken, but it compiles. But now we can say log comp exchange directly here. Just say return log comp exchange test old new. I just want to make sure that I didn't mess up the atomic compare and swap calls. Where are they? They were not here. This is new old, new old. Okay, just wanted to be sure because they're flipped. Okay, and now we can use the same everywhere else we do log comp exchange. Anywhere in modules. The extra temporary move is to work around a bug in the compiler. I'm not sure what this one is. We do this a lot. Oh, and we need it for all the sizes. No. Oh, we even have a 16-byte version. So we would do if size is 16, do this. Okay. If size is 1 or size is 2 or size is 4 or size is 8, then do actual old is I see. We're interested in the success flag. Oh, we don't get that from our intrinsic. We would have to say success equals. Yeah, thanks, Kuyu. Thanks for helping me out. sorry that we didn't get very far into the actual Wasm stuff because we hit this one initially, but I think it's important to get this one right because it's right in runtime support. Anyways, time to hang out. Good night. God, it's like 3 or 4 a.m. at your place, right? See you. Thanks for giving me the primer, and we'll continue this. Yeah, the beep was the mention alert, exactly. So here we would say lock test old new and then we would return actual old. When we want success, we say old equals actual old, which sucks. Like, this is now slower than it was, but okay. And we just keep the 16-byte value for now, for here. For now in here. And of course 1 and 2 aren't implemented either, but baby steps. So this is now, wait, what's rpmalloc raw? What is this doing? Ah, use raw, okay. You know what? Maybe I shouldn't replace all of them right now. Let's try to get this working. That's gonna be hard enough. Boom! Awesome. Everything fails. Oh yeah, with x64, of course. My bad. We didn't implement x64. Okay. Let's close a bunch of these 2000 tabs. So what's the problem with this one? Let's start here maybe. Which is a match of possible overloads. Type 132 given pointer to S64. Really? Did I mess this up so bad? That was in atomics. This is pointer to blah. this is in feature intrinsics. Here. So we say this is a pointer to I64 and we give it temp and temp2. What? Let's try it again. So at this site, 250, 215, I mean. No, was it? It was, yeah, 215. In test features intrinsics. We do the 64-bit version. We have a pointer to 64 and two 64s. And this doesn't match. Because we say type wanted pointer to S64, type given pointer to S64. That's true, because we say pointer one, they're all so we're doing the pointer version. Not the x64 version, we're doing the pointer version. And I guess we don't have one of those. Because I defined the log comp exchange as just, yeah, we don't have a pointer version. Maybe we should instead say this is pointer to void, pointer to void, pointer to void. No, this is pointer to void, and this returns a pointer to void. And have like, we just have the signed versions. If we want unsigned versions, I'm not sure. That's all of them. One second. Bye, Jumpy. So since we've stopped the chat with Kuyu, I can drop the phones and we can switch this back to I'll have to switch the multi one to, yeah, let's just do this, whatever. Okay, so what's your problem? Possible overloads. They are all wrong. Type one, pointed to pointed void. Okay, we just have to cast in every case. Then let's do that. So this is cast pointed to void. Cast pointed to void. Cast pointed to void. How about that? Still grumpy. Oh, same here. Cast pointed to void. Actually, I'm not sure why we're not casting the pointers, but whatever. Like we could do it here by casting them once, but what are we doing? We're swapping pointer 1 and pointer 2. Wait, what are we trying to do here? Let's look at the actual thing. So temp is 4. Temp 2 is also 4. And then we say this one points to actual I64, and these are different, obviously. They point to different variables. And obviously this is not correct, so pointer 1 is still pointing to I64. Yes. Okay. And then I'm swapping pointer 1 with pointer 2. So pointer 1 now points to temp, which is the same thing as pointer 2. Oh no, we're swapping. Wait, we're swapping. So no, that's fine. We get the old one back. The old one is this one. But now pointer 1 is the same as pointer 2. So when we do compare and swap, this now is true and now it's 3. Yeah, that's okay. I get it. This is fine. So what's your problem? Oh, we do it with an enum. And this one complains. You know what we could just do? I don't know. Okay, this is stupid. I don't know to which one I should cast this. That's the problem. So we have a couple of declarations for comp exchange, and I don't know which one to cast to depending on the size. So I would have to have still have separate versions for every size here. So I would have to keep this basically. And do the explicit cast here in case the T doesn't match up. That's what I mean. I do the same thing here and here and here, and then this is just 16, 32, 64, and I should have done it horizontally first. 16, 16, 32, 32, 64, 64. And we could instead make this a pointer to void, pointer to void, pointer to void, and we don't need both cases maybe. how this should work. Mismatching levels of indirection. So this one has to be cast T. Okay, let's see if this actually runs. Seems like it worked. Yeah, for some reason, for tests like this, I like to just say, so you can clearly see that it doesn't crash without, like, especially on Windows, where if something crashes, you don't get any like stack trace, etc. by default. Well, okay. Now we have the problem that this doesn't run with x64. Okay. So we need to implement it in the x64 backend, and also, but hey, good news is this thing just ran. Like, we're on the right path. So if we do this again, and we look at the disassembly, and just to see if we actually got locked comp exchanges, maybe that's a good idea, right? If we look at the disassembly for atomics, come on, LDB. Show me the disassembly for this one. Well, I guess it's a large one, and showing the disassembly sucks in LDB. We call into compare and swap. Okay, that would have, I could have thought of that. It's another call. Why is this mapped as a call? And I couldn't step into it. That's not what I expected. Also, the overhead is now way higher, which also sucks. Maybe this was a bad idea. Let's try this again. We are in atomics. Blah 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 blah. Where's the lovely pointer? There. We're calling into compare and swap in atomics. If I step into that, and I disassemble here, Lib compiler runtime. What? There's the log comp exchange. Yay. But instead of this being a single instruction, we have like calls after calls after calls. There's a call to a dynamic library that's called libcompiler.rt. This is so far removed from what we wanted, which was a simple compare exchange instruction. That's why I'm like, yeah, maybe this shouldn't be so much overhead. Like, you know what I mean? Like, have you seen through how many instructions we just stepped? I thought the LVM IR would convert this to a... Maybe this is because we're in debug build. Let's see what the release build looks like. Because this, what we just looked at was god-awful. I think you might agree, right? Let's do it maybe next code, because it's slightly less of a pain in the rear to step through disassembly, because I don't have to reprint it after every step. Jai tests. Nope, not sub. Tests features intrinsics. And we want atomics. If it still exists in the release build, of course. Looks like it still exists. That's nice. If I step into that, okay, we're immediately here. And now let me please show me the disassembly. Hello, I thought I had it on. I thought I had it mapped to this one. No. Debug workflow. Oh, we should have control. Oh, okay, this one. No, it's still a call to compare exchange. That's no good. Let's see what kind of a mess this is. Still a dynamic. Look at this. Like, this is supposed to be roughly this one. And we have like, even release builds, like look at this crap. I'm not sure if that's a good idea to eat this overhead in the x64 backend, like not the x64 backend, in x64 builds for comp exchange, just so we can have the generic LVM version. You know what I mean, right? Okay, this one has all the different size. We're comparing sizes, I guess. So you have a comp exchange for a byte. You have a comp exchange for long. You have a comp exchange for 8 bytes. Do I plan to use Jai for something exciting once it's done? I'm already using Jai for something exciting. And many other people are. Yeah, this doesn't feel good. And this is now a release build. Remember that. This is the release, like the LVM release build. That's supposed to be the optimized version. And we have this kind of crap for a comp exchange. I mean, the good news is this should now also work on ARM, etc. But I'm not happy. We could, of course, avoid some of that by saying if CPU is x64, do the old stuff, else do that, to avoid the overhead for x64. But then again, why did we add the intrinsic if we still have an assembly an assembly version of that? The whole point was to get to deunify that. So this is the old code. Like, of course, you can leave this in here to avoid the overhead, but it seems a bit stupid to have now both the ASM block and the intrinsic. It sounds like the worst of all worlds. And here we would also have to say if blah, otherwise do this nonsense. And the question is also, why do we get that overhead? Let me look at what this turns. The preload compare and swap, what this turns into in an optimized build. So if we go here and I add another breakpoint, and hope that this still exists in the optimized build. Yes. See, that's what it's supposed to look like. Like, bit of a mauve, lock, comp exchange, done. And compare that to the nightmare of a crap that we now get in here, where we have a bunch of overhead to call this. And then in there, a bunch of more overhead. I don't know. It feels wrong. I don't know what to do about it. Do you have any advice for dev in the USA trying to relocate to Germany? No, not really. I haven't done that. Sorry. Like, any advice I'd give you is ill-fitted. I've worked on projects in Germany, but nothing that would generalize. Learn German. Yeah, that's a good advice. I'd say I'd probably say, why would you want to? Like, I have the feeling just from where the US is heading and where Germany is heading, I'm not sure if I would move in that direction. Like on a macro perspective, but that's something else. Yeah, I don't know what to do about this, guys. Yeah, we have now something that works on non-XT4 targets using the LVM immediate representation, but it's crazy overhead. Yeah, that's with LVM optimizations. That's the insane thing. We're doing a release build, and the result is like 30 assembly instructions for something that should be 4 or 3 or something, that like an order of like factor of 10 overhead for something that shouldn't have any overhead at all. So I don't know. Feels bad. How long does this take? Yeah, so this is a 0.24 seconds. That's the LVM backend take in the debug build. I just wanted to see if the optimize extra runs. And now it's like 1.4 seconds with release build. But it's awful. Where the extra instructions coming from? That's just what the LVM intrinsic converts to for some reason. It just calls, it doesn't actually inline, it doesn't convert into an assembly instruction. It actually calls a compiler RT function, which is the runtime library for Clang, I think. What does it say here? So this is what ships with LVM, and it links against that, and that one has a runtime implementation that switches, depending on the size, I guess, I don't know, between the different comp exchanges. And I don't know why it does that instead of just inserting the comp exchange. But this is what the LVM, to me, like, unless we did something stupid that prevents the optimizer from doing the right thing, but then I wouldn't know what. We convert this lock comp exchange call into, where is it? Create the atomic comp exchange. And this create atomic comp exchange seems to be converted into let's go there for a second. Wait, is this now the release build? I think it's release build, yes. If you look here, this it's converted into a call to atomic compare exchange, which comes from, damn it jumped over it. So if we look here, and this is in libcompiler.rt, so it's a call into the dilib, and we walk through the whole thing where we see we see that there's a comp exchange for bytes. Incidentally, I didn't see a comp exchange for a short, but I see one for a long, and I see one for a quad. And that's just what we're doing now. Like, if you see, we just jump down here and then we do the, where is it? Let's just look at what's happening. And then we finally have a lock comp exchange. And that, to me, that seems unacceptable, that overhead. We can do the following. Emit IR, I think we call it, right? No? What was it? Output IR, damn it. Emit output. We can look at the IR and see if we generate the right IR. So if we're to blame or not. I assume we are to blame, but I wouldn't know how that happened. So let's look at the optimized version. And we should see a CMP. Come on, Vim, I know it's hard. It's a lot of bytes, but you can do it. CMPX. That's not what I typed. Vim can't even, the file is so big that Vim can't process my input correctly. This is nuts. CMP, and it types CPP. Did you see this? It can't even do input right. CMPX. Yeah, so compare and swap. We give it a comp exchange. Okay. And this comp exchange converts into a call into compiler RT. So I think we're doing the right thing. It could be that some of these things prevent it from, like that we're doing something that prevents it from inlining that call, but I wouldn't know what. Which platform is this happening on? What do you mean? Are you talking about the Vim nonsense or the comp exchange nonsense? On macOS, on x64 macOS, we're debugging x64 macOS using LVM16 to generate the code with the optimizer turned on. And like, even if we do some nonsense so that it can't inline this code, which I'm totally willing to accept, this should still turn into a comp exchange and not into a call into compiler RT. Calling the interface directly in the dummy program. Yeah, how would I do that? Like, how would the equivalent C code? How would I trigger that in C code? Or do you mean I just define the, like we could just take the example that they have here somewhere. And look at that. But like writing IR from hand sucks. So I don't want to like do that, honestly. What could we do? Just seeing if there's someone. Like, what's the easiest way we could? What's the easiest thing we could do to just try? A comp exchange call directly. I guess. I guess I could copy this one and then just create an LVMIR where I just call this function and see what this generates into. What this converts into, I mean. Problem is I'm not good at writing LVMIR. I wouldn't even know what all the crap is that I need to put at the beginning, at the end, to just make it not barf. You know what I mean? Like how I need an empty LVMIR stub basically to put that into, or I don't know. But as far as I see, like, this is what we're calling. I don't see how we could, I don't know. I mean, we can Google for the behavior, but LVM CMP exchange, and this turns into, what did we see? Atomic symbol stub for it turned into a symbol stub for atomic compare exchange, right? If we look here, yeah. It doesn't keep the step single instruction. It is compiler RT, right? Let's just make sure that I got this right. If we step until we have the call. That was in libcompiler RT, yes. That sounds good. Does it say anything about atomic compare exchange? Okay. Oh. So the problem is that it's not aligned. It could be that this is like the cause for that, for this call is the line one. Let's figure that out. if we say here, do we ever do this with a non-1? Get alignment, and we want it for the value type of good question, probably the pointer. Just looking. Let's try that. So maybe this triggered it. That's a good pointer. Okay, it took a bit longer. Let's see what the IR turned into. Comp exchange align 8 sounds better. Let's see what this turned into. So, hey, see, now this is way better. Okay, now I'm happy. So now this code turned into lock comp exchange. Victory. How did the Wasm stuff go? We're still not even close to trying. Yeah, baby steps, man. Baby steps. But the good news is that means we can actually use this, which means we don't need this. So we can actually start replacing those, which is good. I'm gonna like commit what we have. This is kind of gross, but well, this one we're gonna commit, the other one we're gonna leave out. Now this trap should work again, but it's interesting that this one, we should try a debug break at compile time, just to make sure that this is fine. And then it's very much lunchtime for me, but we're making progress. What happens if I try to compile this? Tend to validate on a compile time procedure. Yeah, so it has to live outside. So I'm not sure. So Ian submitted this part of the code where this is outside. Does not work. So we have to put it here again. There were errors on workspace 2 exiting. Really? Debugger. Yeah. Okay. that works. Seems to work, I should say. Okay. So we do this. Let me just make sure. Okay, we should keep that comment though. Okay, but we got one of the big things out of our way, which is good. Let's just, we haven't implemented the x64 version yet. Custom code per intrinsic. No, this is just, the problem is that comp exchange is not an intrinsic. That's the thing. So I thought it was an intrinsic, but it's not. It's actually IR code. So we can do intrinsics just fine, but if you look here, this is not an intrinsic, this is a bytecode instruction comp exchange. Not the same. Okay. So the LVM intrinsics we can still do, but this is not comp exchange is not an intrinsic. So we had to add special code for it, unfortunately. Okay. I think I'm gonna stop here and have a lunch break because I'm getting really hungry, but we're gonna get back to this right after lunch. One thing we still need to do is implement it in the, wait, what was this? That we figured out. I want to keep this one for now. We have to implement the 1 and 4 byte versions also. And I fat fingered this one. Yeah, but we're getting there. Hey, Ian. It's going well. Well, it's going slowly, but we just got rid of the comp exchange part here by adding an intrinsic that should now work on all platforms. Except that I haven't implemented it in the x64 backend. So I need now to encode the lock comp exchange for x64. It's not hard. It's just something I need to do. We can even look at the LVM machine instructions. The machine instructions the LVM generates and just feed that into the x64 backend to generate the right instructions. Or we could just look it up. Where is it? Here, what the encoding is. But that's something I need to implement after lunch. And then we need to implement it for 1 and 4 bytes in the LVM backend. And at runtime, at compile time. And then we can continue getting rid of the other x64 things. But getting rid of comp exchanges already is going to get rid of a bunch of assembly blocks. Yeah, and then we'll see. Anyways, I think I'm off to lunch. I'll be back in half an hour or something. So thanks for coming by. See you soon. If I'm not back, something happened. Well, then we see each other tomorrow or whenever. Bye.